Good morning, ma'am. Ma'am. Sharath.
Hello. Hi, can you hear me?
Yes, ma'am. How are you, ma'am?
Yeah, good.
Fine, ma'am.
Good morning. Good morning.
Good morning, ma'am. Sure. You are in home, ma'am, or came to the college, ma'am?
No. I'm here only since 1st August. Yeah.
Yes, ma'am. I met Sharath and he told, ma'am.
Yeah.
Fine, ma'am. It is very great in this moment also. Without a take rest, continuously you are working and making things. Really great, ma'am.
This is all what keeping us alive.
Okay, fine. Sure.
Yeah. Good morning, ma'am.
Hello, how are you?
Hi, good morning. Good evening. I'm
Yes.
good. How are you?
I'm doing pretty good. I'm doing pretty good. So looking forward to this. So thank you so much for the invitation. So I'm just going to enjoy listening to everybody today because I believe I'm on schedule for tomorrow, if I read that correctly.
Great to have you here in the inaugural ceremony. So please be there.
Yes, I will. I will.
Thank you. Good morning, sir.
Good morning, madam. Everything is okay?
Yes, sir. Looks like we are ready.
No, it will. It will. Don't worry. And this corona has helped us a lot. We need not travel. We can sit and then we can always connect with the people.
Absolutely.
It's a
Yeah,
good thing.
that way.
One way or other, it is good, but we have to also struggle.
Yes.
Did you
Good
verify
morning.
with the Vice Chancellor office?
Sir will not be able to make it today, but
Okay.
yeah, so he gave his wishes and blessings to continue the program.
Okay.
And
How about registrar?
he will be there. He said, yeah, he
Okay.
confirmed. Ma'am, good morning, ma'am. We can't hear you. You're muted.
Good morning, Dr. Chakraborty. Would it be possible for me to share the screen? I have a few slides during my presentation.
Yes, ma'am, you can.
Okay.
You can give it a try now if you want.
Okay, sure. Or somebody else is sharing, so then is that okay? Can I just?
That's fine, ma'am. Whatever
Okay.
you're comfortable.
Okay, let me just try. I think unless somebody else stops, I would not be able to. That's fine. So
Can you, ma'am, please try to hit the share screen button and see if it works for you?
it says as long as somebody else is sharing, I'm not able to.
Okay, just give me a second.
Yeah, now I'm good. I'm hoping you can see my screen.
Yes, ma'am. We
Perfect.
can see your screen. Yeah.
Okay.
Thank you. Thank you very much for accepting our invite.
No problems. Thank you. Okay, so I will switch off my stop share. Okay.
Good morning, sir.
Good morning, madam. Good morning to all.
Good morning, everyone.
Good morning.
Good
And
morning.
good evening for you, Professor
Yeah.
Alan.
Dr. Paramita,
Yes, sir.
you request registrar to give the presidential address because Vice Chancellor will not be joining.
Yes, sir. Yes.
Yeah.
Good evening, Professor Ray.
Good evening. How are you?
Yeah, good, sir. Great to have you all here today for this program.
No, thank
Good
you very
morning.
much.
Good morning, Professor Napoleon.
Good morning, ma'am.
Yeah, good morning, Sanjeev.
How are you, ma'am?
Good. Great to see you here.
Thank
Yeah.
you, ma'am. Same feeling here. Yeah.
Sir, we'll wait for 2 more minutes to start the program. Good evening, Professor Jay. Good evening, Professor Gan, Professor Shannon. It's great to have you all here, and I think we can start the program now. Professor Dan?
Yes.
Yeah. So should
Good
we
evening.
start? Yeah.
Yes.
Good morning, respected dignitaries, my colleagues and dear participants. During this auspicious occasion of our Chancellor's birthday, I sincerely thank you all for finding time and participating in the Indo-US bilateral workshop on Water and Air Resource Initiative for Societal Health, WaARISH 2021. It's said that by means of invocation, the beginning awakens and awakening becomes fullness. By means of balancing, fullness becomes internal wholeness. Let us all rise for the invocation song.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Now, I would request Director Research, SRMIST, Professor K. Ramasamy, to welcome the gathering.
Respected Registrar of this esteemed university, Dr. Nandini Kannan, Executive Director of Indo-US Science and Technology Forum, Professor Chitranjan Ray, Nebraska Water Center, learned participants and invitees for this international webinar, Dr. Sachita Tirupati, Jesse Bell, Dr. Kari, Dr. Allen, Dr. Shannon, Dr. Chitranjan Ray, Dr. Jake, and Dr. Daniel Snow. My dear faculty members, student friends, and PhD scholars, good morning to you all. At this juncture, the Directorate of Research is happy to welcome you all for this webinar, and it coincides with our Chancellor's, Founder Chancellor's birthday. And as a unique institution in India with A double star, and the university has also launched a student satellite which is still functioning for the past 11 years. So India, after the tragedy of Bhopal, started the environmental department. Slowly it added the forestry also into it, connecting the forest resources, helping in carbon dioxide fixation and reducing the pollution, besides aerating the roots ecosystem. India has done a lot in water purification and providing quality drinking water to the mass. And it has also tried its level best to reduce the atmospheric pollution. It has moved away the boundaries from the city to the outskirts, reduced the air pollution, particulate matter associated with those things. And this initiative of Indo-US Science and Technology Forum to organize this webinar is very timely, and I sincerely congratulate our staff members, Dr. Paramita Chakraborty, coordinating all these, her effort. And her effort during this pandemic is also recordable. She has developed the system to assess the virus associated with corona and predict from the sewage system so that we can forewarn the public. This is a very phenomenal contribution for the country. At the same time, she is also associated with international fora for quality water assessment and management. She is also helping the globe in association with Norway, Sweden, European countries, and US. Such a collaboration at this young age will take this university to a successful venture in contribution of scientific evidence to control the environmental pollutants associated with industrial discharges and the corporate sewage discharged into the natural receiving bodies, not only in India or in all the developing countries. Any resource and any technology developed by the scientific community is made available to the open science so that everybody can use it. On behalf of the SRM, Institute of Science and Technology, faculty, resource persons, our research scholars, student friends, I sincerely welcome you all for this international webinar. Purnanda.
Thank you very much, sir. Your thought-provoking address set a perfect platform for our speakers to deliver their presentations that deal with the current challenges faced in the areas of air and water pollution. Now, I call upon our beloved registrar, SRM IST, Professor S. Ponusamy, to deliver the presidential address.
Dr. Nandini Kannan, Professor Chitranjan Ray, Professor Ramasamy, Professor Daniel Snow, Dr. Paramita Chakraborty, and other dignitaries, all the participants and my dear colleagues, a very good morning to all of you. Indeed, it gives me a great pleasure to be present here on this day to address this virtual gathering. The air and water we depend on for our survival are under significant threat from many different causes. In this time and age, where everything is available instantly, we have never paused to think at what cost that convenience comes with. At this crucial juncture in humanity's timeline, we as a generation have yet to come together at a global level and unite to restore balance to the environment. This workshop, where bright minds from the West collude with the brilliant minds of the East, is a welcome initiative. Even the title of this workshop reads Water and Air Research Initiative of Societal Health. Initiative is important. Establishing ties and forging new friendship are necessary and are often the key to handling many of the society's problems. I laud the efforts of the conveners under the Indo-US Science and Technology Forum, the Daughter Tea Water for Food Global Institute, and our very own SRM IST for coming up with this event. I'm sure this will prove to be incredibly beneficial and leave a significant impact on the participant and research community as a whole. And I wish for the successful completion of the workshop and eager to learn many new things from it myself. I congratulate the team from SRM for having arranged such kind of workshop, and thank you one and all.
Thank you very much, sir, for giving a brief insight on the importance of the WaARISH workshop and encouraging. Now, I would like to request Professor Daniel Snow, Convener USA, to deliver the convener's address.
Well, thank you. I appreciate the opportunity to convene this workshop. I have to say it's been quite rewarding to work with scholars from India in the past several years through the collaborations that came about with the Water for Food Institute. I'm very excited about the speakers that we have in the schedule for this workshop. And I'm also excited about the topics and the new researchers that will be presenting their expertise on this agenda. I'm very grateful to SRM University for hosting this workshop, and especially grateful to the IUSSTF program for providing funding for this event. So with that, I'm going to turn it over to our other convener, Paramita Chakraborty.
Thank you very much, sir, on giving your valuable insights and helping us understand the importance of WaARISH 2021 workshop. Now, I would like to request Dr. Paramita Chakraborty, Convener India, to deliver convener's address.
Good evening, everyone in US, and good morning, everyone here in India. Today is a big day for SRM fraternity. It's our Honorable Chancellor's birthday today. We wish him a blissful year ahead. His blessings and encouragement has helped all of us to grow. Well, in our current environmental challenges of climate change and many other issues are either directly or indirectly a consequence of our incapability to effectively handle our wastes. A simple act like flushing the toilet uses far more resources than necessary to accomplish the task. And wherever there is overutilization, there is an increased tendency to waste than conserve. Industrial emissions, vehicular emissions are all nothing but waste gases and liquids being released after use. Through the air, through water, all the wastes of the world have crept their way back into our lives, threatening our very existence. But the human spirit is resilient. We are learning our lessons and coming together to tackle some of the biggest environmental issues at the global level. The research community is always on the frontiers of any great endeavor all through history. It is the researchers who are there on the front lines, leading the charge for the rest to follow. Pollution has now become a commonly used word in our everyday life, relating to the destruction of the natural air we breathe, the water we drink, and the land we live on. It can be defined as the undesirable and unintended contamination of the environment by human activities such as manufacturing, waste disposal, burning fossil fuels, etc. As citizens of this planet, we have gotten used to reaping the benefits of advanced technological improvements and rapid industrialization. Even today, we don't stop to think of what kind of impact our everyday lives have on the environment. The air that we breathe, the water that we drink, they're all affected by anthropogenic activities. Mindful consumption, responsible disposal of wastes are the need of the hour for the general population. The Water and Air Research Initiative for Societal Health, WaARISH 2021, this Indo-US bilateral workshop is an attempt to bring together the brightest minds from the West and the East and showcase the research community's efforts in combating current environmental problems. I hope everyone is able to benefit from the talks of our esteemed speakers and early career researchers, and also from the students' poster sessions. It would be a lot of fun here. We are all here with us today. I really thank everyone, all the participants, and I wish everyone all the best for this workshop. Hope it gives us a successful day ahead in the next 2 days. So I welcome you all once again, and thank you. Thank you very much for being here for this workshop.
Thank you very much, ma'am. Your address allows us to better understand our understanding as a society in terms of air and water pollution. It is my privilege to introduce the chief guest of the day, Dr. Nandini Kannan, Executive Director, IUSSTF, to the gathering. Dr. Nandini Kannan is currently serving as the Executive Director of the Indo-US Science and Technology Forum, IUSSTF, a bilateral autonomous organization jointly funded by the Indian and United States government to promote science, technology, engineering, and innovation through substantive interaction among government, academia, and industry. Dr. Kannan has spent over 20 years in academia, first as a faculty member and then as a chair Department of Management, Science and Statistics at the University of Texas at San Antonio. Since 2014, Kannan has served as a program director at the US National Science Foundation, NSF, where her responsibilities included co-disciplinary research, mathematical science research institutes, and workforce development programs in the Division of the Mathematical Sciences, as well as number of cross-doctorate and cross-agency activities. She also serves on the board of trustees of the International Indian Statistical Association, IISA, and is a former president of IISA. Dr. Nantini is a fellow of the American Statistical Association and as elected member of the International Statistical Institute. I kindly implore Dr. Nantini Kannan to address the gathering and deliver the chief guest's address.
Thank you very much for the invitation. I'm just pulling up, I have a few slides. I'm just going to pull those up in a minute. Perfect. Thank you so much. So I would like to start by thanking the registrar, Dr. Ponnusamy, the Director of Research, Professor Ramasamy, of course, the two conveners, Dr. Paramita Chakraborty and Dr. Daniel Snow, for organizing such a wonderful event. And thank you all for the invitation to come speak. This is, as every one of the speakers ahead of me have said, this is a critical area for both India and the US, and in fact, the entire planet. So I'm delighted to see a workshop that's looking at not just research in water and air quality, but looking at the societal impact as well. So this is a slide that I think is perfect after we've heard the opening remarks. This is a slide from the OECD that talks about international science collaboration. This is, of course, related to COVID-19 research. And you can see from the screen, on the left are the top 5 countries in terms of COVID-19 research publications. And then on the right, you'll see the countries, the collaborations. So this really in one graph shows you how much collaboration has happened in the past year and a half. And that, of course, has led to countries being able to produce vaccines in record time. So this sort of gives you a perspective on how global collaborations can really help accelerate research in some of these very pressing societal problems. So this is something that I really don't have to tell all of you, but I'll bring it up anyway. Why international collaborations? So one thing we know is societal challenges, no geographic boundaries. So we're looking at things like water and air quality, climate, sustainability, energy, public health. These are all issues that affect everyone on this planet. Global challenges require global collaborations and partnerships. We need to bring together the best and brightest scientists, engineers, and entrepreneurs, just like you're doing today. Collaborations and networks help to leverage and share expertise across the different science and technology communities, helping create synergy. And what's critical is these collaborations help to accelerate progress that could lead to breakthroughs and generation of innovative and transformative solutions to some of these big societal challenges. And finally, last but not the least, what collaborations do is to help develop a diverse, globally engaged science, engineering, and technology-abled workforce. And I'm delighted to see poster presentations by students and the ability for graduate students and postdocs to make presentations and hear from leading experts in this area. So to summarize, why global collaborations? One is, of course, access. We have limited resources. We want to access research expertise, unique perspectives and approaches, unique facilities that are available around the globe, and of course, different test beds for many of these unique challenges. We want to leverage the resources that are available in our science and technology communities across the world. We want to share insights and knowledge, and one of the things we've learned in these past year and a half is the role of multidisciplinary research. And I can see from the team that is assembled here today, you have the entire spectrum. And of course, international collaborations help to create these networks and this globally engaged workforce. So a little bit about the organization. You've already heard that we are a binational entity. We were established in the year 2000, so 21 years ago, under an agreement between the two governments. In India, we work with the Department of Science and Technology, and in the US with the State Department. And we operate through two bilateral agreements between the two governments. Our vision is simple. We want to excel in the science, technology, and innovation space through collaborative initiatives between the two countries. We do that by acting as a catalyst, so funding workshops and networking opportunities that help to promote long-term collaborations. And we also establish platforms and mechanisms to help connect the S&T ecosystems of both countries. Our program portfolio is quite diverse. We have scientific networks. So the event today is funded through our bilateral workshops program. We also have a portfolio in innovation and entrepreneurship, taking S&T from the lab to the market. So for commercialization, again, bringing together US and Indian teams. We have a research and development portfolio, and I'll highlight one of the programs here, which is a joint initiative between DST, Intel, and our USSTF. It's called River, Water, and Air Quality Monitoring. And I see Dr. Sachidhat Tripathi is going to give a talk today, and he's one of the PIs for one of these projects funded under the WAQM. And then, of course, we have a large number of visitation and fellowship programs starting at the undergraduate all the way to the faculty level. One of the programs we're really proud of is, again, funded by the Department of Science and Technology with the University of Nebraska at Lincoln as a partner. It's the Water Advanced Research and Innovation Fellowship Program. And I'm delighted to tell you that Dr. Paramita Chakraborty was one of the early awardees under this initiative, and she visited Nebraska to collaborate with Daniel Snow. So it's always very gratifying to see these events come together. So from one fellowship to one individual faculty member, you've built an entire community around this area. So to Dr. Chakraborty and Dr. Snow, we want to congratulate you, and we look forward to great things from this workshop. And lastly, our USSTF has this sort of unique role. We try to identify leading edge areas, high priority for both countries. We leverage our networks, bringing together stakeholders representing all these different entities. We support workshops and networking opportunities to both initiate new collaborations and help to cement partnerships. And we also have the opportunity to recommend priority areas for US-Indo collaborations, including joint funding calls. So one of the initiatives we've stood up in the last few months is one on AI. So it allows us to strengthen our strategic partnership, looking at AI cooperation. Again, we're leveraging the strengths of our communities on both sides, engaging both the Indian diaspora and the tech companies in India. And I'm bringing up AI because it's also a critical area within the discussion around climate and energy. You're dealing with lots of data now. With COVID, you've generated huge amounts of genomic data, public health data. How do you leverage all these data to make predictions? So AI is not just a domain in computer science. It's going to be the tool that's going to help solve some of these very critical problems. So we'll be having events through the year on AI, and I hope some of you will join us through these activities. And again, thank you so much for the opportunity. I wish the workshop every success. We're certainly looking forward to hearing what comes out of these discussions. And if there are some great ideas for collaborations, please do not hesitate to reach out to us. Thank you again to Dr. Chakraborty and her team. And I really appreciate the opportunity to be part of this. So thank you so much.
We are all grateful for your thoughtful words, ma'am. Your eye-opening insights have truly made an impact on everyone present here. Next, I would like to introduce our chief guest of honor for the day, Professor Chitranjan Ray, Director, Nebraska Water Center. Professor Chitranjan Ray was a professor of civil engineering and interim director of Water Resources Research Center at the University of Hawaii at Mano, which like the Nebraska Water Center, is a part of the network of more than 54 water resources research institutions created by congressional legislation in 1964. He has served as director of the University of Hawaii's Environmental Center and chief environmental engineer for the Applied Research Laboratory, a U.S. Navy-sponsored facility on campus. Professor Ray has held positions in industry and at the Illinois State Water Survey. As a holder of the PhD in civil engineering from the University of Illinois, he has extensive experience in many facets of managing both water quality and water quality issues. He is also an active member in the American Society of Civil Engineers. In August 2013, Professor Ray became the permanent director of the Nebraska Water Center as a part of the leadership term at the Robert B. Doherty Water for Food Institute. It is indeed an honor to invite you, sir, to share your words with an eager audience.
Thank you very much. It helps me to go after Dr. Cannon because she has already introduced the bilateral relationship and the IUSSTF programs. So a little bit about myself. As I was introduced, I received my PhD from the University of Illinois and worked at various institutions here. But I still maintain close contact with Indian colleagues. 2004, I spent 6 months under a Fulbright program focusing on riverbank filtration technology for drinking water supply in the Gangetic plains of India, Nepal, and Bangladesh. And the Fulbright gave a little bit of money to hold a workshop in Roorkee. So I had some German, Austrian colleagues, and that effort really led to significant amount of collaboration with IIT Roorkee, National Institute of Hydrology, the Uttarakhand Jal Sansthan, and various entities in that area. My colleague Thomas Grischek from Germany has been quite active in this area with the Indian colleagues. I'm also the main coordinator of the WaARI, the Water Advanced Research and Innovation Program, between the IUSSTF and DST from India side and the University of Nebraska this side. With funding from the IUSSTF, maybe 3 or 4 years or 5 years back, we did a workshop at the Indian Institute of Science in Bangalore on the nexus of food, energy, and water. It's a little bit late, but an edited book volume is coming out this November by Springer from that work, and we'll be sharing that with the IUSSTF once it is out. So it basically involves some of the faculty members here who are present here in this program, as well as a number of Indian colleagues. And I'm also collaborating with Indian Institute of Technology, Bhubaneswar, Ajay Bajra faculty, but because of the COVID, things have been a little bit delayed right now. So let me just mention a little bit about the WaARI program, what Dr. Cannon mentioned, and also many of the attendees here were in the first or second batch. As Dr. Cannon mentioned, that it is funded by DST. And the initial partnership was with the University of Nebraska in the US, and focus was on water quality and the related topics. But after the first 3 years, the program was renewed for 3 more years. That time, the executive director of IUSSTF asked me to include a few other institutions for competitiveness. So for year 5, we got consent from 3 other universities, Purdue University, Texas Tech University, and University of Idaho. From Idaho, we have a colleague here, Dr. Alan Kolok, who is the director of the Idaho Water Resources Institute. But because of the COVID, this program was canceled last year. So each institution, the 3 institutions we brought in, they provide modest amount of support for lab expenses and the housing for the students and the faculty or researchers. So it is a pure research exchange program where the junior faculty or government lab researchers can spend up to 1 year at a host laboratory, and the doctoral students can spend up to 6 months at the host laboratory also. the process is very competitive. The mentor and the mentee have to work together to develop the research proposal, which is evaluated by DST, the University of Nebraska folks, and finally a panel that physically meets in Delhi every year to select the finalist students and the faculty or researchers. Many of the WaARI alumni are faculty members now at prestigious institutions in India. And I feel really lucky in that extent that long ago, there was a program at Harvard, Harvard India program. Dr. Peter Rogers used to run that. Actually, he ran for 15 years. Dr. Rogers was one of our international advisory panel members, and he passed away 2019. Actually, I had the good honor to meet him a few times over the years. Then the WaARI scholars continue publishing with their mentors and collaborators. US faculty mentors got the opportunity to visit India through Aussdf sponsored workshops. I recall several of them have already taken place, one at BHU, and this is the probably second or third one now. And some of the WaARI doctoral students also were sponsored for a postdoctoral research at various labs here in US. I have a few suggestions, probably particularly for students who will be looking for WaARI related fellowships or internships. The main thing is the problem statement should be more relevant to India. There is no point to copy what the US scientists are doing. So this is one of the things I feel can strengthen, particularly the present government and various bodies in India. When they are focusing on development of India, there are plenty of topics we can really focus on those and use this collaboration as a tool to solve the local problems. A lot of times I saw proposals coming on microbial fuel cells, but why not problems on a low cost drinking water supply or a low cost waste disposal or ways to remediate hazardous waste sites. In the, I think in my home state of Odisha, there's one Sukinda mines area that's one of the worst 10 polluted sites in the world. So that could be something to consider as a way to do collaborative research. So problems may focus on helping the poor in the WASH sector, water, sanitation and hygiene sector, food, energy and water, as well as global issues of hunger, resilience, climate resiliency, all those areas. And this is where my sincere request, and this is also Professor Ramasamy also mentioned that the problems have to be local problems. This is where benefit goes to both sides, that we can help from this side what we are doing, but at the same time the people of India get the benefit. And with that, I thank you very much for giving me the opportunity to speak for a few minutes here.
Thank you very much, sir, for giving us an idea on the exposure of Indian research in the area of environmental management. Now, I would like to request Dean Research, SRM IST, Professor B. Napoleon, to deliver the vote of thanks.
Good morning to one and all. At the outset, it is my pleasure to propose a vote of thanks on the Indo-US virtual workshop, WaARISH. I, on behalf of the SRM IST, on my own behalf, I extend my heartfelt thanks to all the dignitaries present, invited speakers, participants of WaARISH, deans, HOD, colleagues, faculty members, friends, and dear students. I express my gratitude to our Director of Research, Professor K. Ramasamy, for giving welcome address and motivating us for continuous learning and research, providing guidance and support. Thank you, sir. I heartily thank our registrar, Dr. S. Konusamy. His presence today on this occasion has immensely enhanced its importance. I once again thank you, sir, for all your synergetic efforts. I would like to thank our chief guest, Dr. Nandini Kannan, Executive Director, Indo-US Science and Technology Forum, for kindly accepting our invitation and gracing this inaugural function and igniting the young minds with her speech. I thank our chief guest, Professor Chitranjan Ray, Director, Nebraska Water Center, University of Nebraska, Lincoln, USA, for throwing light on WaARISH. I thank you, sir, for all the synergetic learning. I now thank Professor Daniel Snow from University of Nebraska, Lincoln, USA, and also the convener of this workshop for all the skillful and inspiring speech. Thank you, sir, for sharing your time and knowledge. I especially thank Dr. Paramita Chakraborty, SRM Research Institute, SRM IST, convener of this workshop, for organizing such a wonderful workshop at the SRM IST. I have seen his meticulous work last few months with a team of members and make this workshop as a highly memorable one for all of us. I thank all the faculty members and research scholars present here for their interest and active participation of this workshop. I thank our friends in the media and their cooperation for coverage of this event. Finally, I would like to thank the opportunity to place a record of our hearty thanks to the organizing committee members from Directorate of Research. My sincere thanks to all the Dean Head of Departments for the active participation. I hope everyone will enjoy and learn new things in the areas of research by learning wonderful invited lectures, which will be given by experts from India and also from abroad through Zoom. I once again thank everyone whose contribution has made this workshop to be a successful one. Thank you, one and all. Thank you.
Thank you, sir. I would like to welcome our session chair, Dr. Purushothaman. Dr. Purushothaman is an associate professor of Department of Civil Engineering and Environmental Engineering at SRM IST. He has completed his postdoctoral fellowship at Research Center for Environmental Changes, Academia Sinica, Taipei and Taiwan in 2009. His area of research interest focuses on environmental impact assessment, eutrophication of surface water bodies, water quality, and hydrogeochemistry.
Thank you. This concludes the inaugural ceremony. So, good morning, one and all gathered here. And as a session chair, I thank the organizers, the conveners for providing me with such a good opportunity to chair this session. To begin with, of our this international workshop, I welcome our first speaker, keynote speaker, Professor Shannon Bartlett-Hunt. Dr. Shannon Bartlett-Hunt is the Donald R. Walte Jr. and Nancy A. Keegan Chair of the Department of Civil and Environmental Engineering at University of Nebraska, Lincoln. Her study focuses on the physical and chemical transport pathways of pollutants such as steroid hormones, antibiotics, and microplastics in soil and water. Her research focuses on the behavior of contaminants in the agrosystems. I once again welcome Professor Shannon, and ma'am, you can take the rest. Thank you.
Thank you very much. Yeah, I appreciate your introduction. I'm just going to share my screen. And hold on, I have to get this into presenter mode. Okay, can you see my slides in presenter mode?
Yes, ma'am.
Okay, wonderful. Well, thank you very much for the invitation. I'm very happy to speak to you today. We're asked to speak about a project that we worked on with one of our WaARI scholars or WaARI fellows, and so I'm happy to present some work that I did with a WaARI scholar, Ipsita Nandi from Banaras Hindu University. So I'm going to talk about some work we're doing with citizen science and water quality. But first, just a little bit of background, which I think everyone will be familiar with. In Nebraska, we have a lot of nitrate in our soil and in our groundwater. The reason for this nitrate contamination is really from land application of manures and commercial fertilizers, which contain nitrate. This map on the side of my slide just shows nitrogen flux for watersheds within the United States. And Nebraska is really kind of right about here in this area where we have very high nitrogen fluxes within our environment. So of course, we need nitrate and phosphate for plant growth. We grow a lot of crops in Nebraska, but when we have excess application of nutrients or when those nutrients run off due to precipitation events, that causes impacts on both health and our water resources. And also just to point out, in the United States, the regulatory limit for nitrate in drinking water is 10 milligrams per liter or 10 parts per million. I'll also present some information for phosphate, but there's not a health-based standard set for phosphate in drinking water. So the focus of our time in this workshop is on water and air quality and health. And so I think it's really important to point out the connections between our water quality and health. I've worked with a group of colleagues, including some of the colleagues who are presenting in this workshop, Alan Kolak and Jesse Bell, to focus on water quality impacts and adverse health outcomes for children in Nebraska. So of course, we know in the United States that cancer is a leading cause of death. And one of the suspected risk factors for development of certain types of cancers could be exposure to environmental contaminants. In Nebraska, we have actually the 7th highest incidence of pediatric cancer. And also Nebraska has quite a lot of diagnoses of pediatric brain tumors. And so there's a great interest in whether or not any of this cause of these adverse health outcomes could be related to impacted water quality. I think also just in general, there's more and more recognition that what happens in our watersheds can affect our health. And so I just want to highlight this paper that was from a couple of years ago, looking at how precipitation and climate could affect geographic disparities in cancer incidence rates. This was specifically focused on the role of nitrate and the conversion of nitrate to nitrous acids or ingested nitrite to nitroso compounds. But again, just starting to be some of the studies that are starting to link watershed quality, water quality, and human health. And then also just pointing out from this editorial that there are very few studies who are explicitly connecting the condition of our watershed with our public health. So this study, which was published in 2018, showed that based on a review, there were really only a small fraction of papers on human health addressed in watershed management, and then vice versa. And if we look at public health literature, people really aren't talking about watersheds. And so the group that I'm doing is trying to help connect those dots. And one example of that, for example, here is some work that I worked on with colleagues on representing adverse health outcomes in terms of watershed boundaries. And so the takeaway message here is just that often our health data is represented in some sort of anthropomorphic boundaries, like a zip code or a county boundary or a state boundary. But when we want to relate this health data to potential impacts from a watershed, it's important that we can use more natural boundaries, such as watershed boundaries, to represent our adverse health outcomes. The data that you see here shows incidence of birth defects in the state of Nebraska, and panel B shows thyroid cancer incidence in the state of Nebraska. And you can certainly see that there are different incidence rates for these two health outcomes across the different watersheds in the state. So when we want to relate water quality and health, we have to, especially when we're talking about cancer, which can have a very long latency period. Pediatric cancer can be, a cancer that occurs in someone from birth to age 19 in the state of Nebraska. We have to have long records of water quality because individuals could be exposed to that water through drinking water or through recreation over very long time periods. And what we find in Nebraska is, although we have excellent databases and a lot of data from various agencies, we still have holes in our water quality records. On the left, you can see here a map of nitrate in groundwater by township, but all of these gray pixels or gray squares are areas where we do not have enough water quality information. And so we still have a lot of spatial areas where we have gaps in our data. We also have temporal gaps in data. So this is just a plot of data that's available for atrazine, which is a herbicide applied in Nebraska over time for a specific watershed. And you can see, because the focus of a sampling effort might move from one location to another, we're left with these relatively long time periods where we don't have enough water quality information. And that limits our ability to correlate our water quality records with our health data. So one strategy that we have employed is to use citizen science or crowdsourced science. And the idea is that we can establish monitoring networks across the state of Nebraska in areas that may have elevated pediatric cancer incidence. We can also provide an educational tool for people living in the state of Nebraska to learn more about their water quality nearby where they live. And so our hypotheses are first that citizen scientists can collect accurate data. I think a lot of times people think about citizen science programming as purely an educational activity, but we've worked to prove to ourselves that with training that citizen scientists can collect accurate information. It's a different type of information. It's lower quality data than you might get from an analytical test, but it can be used to form or test some different types of hypotheses. Also, one of the benefits of citizen science is that it allows for testing over very large spatial or temporal scales, and it may help us fill in some of those gaps in our data records that I just showed. So really quickly, I'm first going to present just a couple of results on our accuracy testing. And this was a study that we published a couple of years ago in Environmental Science and Technology with IPSIDA as one of our co-authors. And so in this study, what we did was two things. First, we took citizen scientists and we grouped them, either someone who is inexperienced with doing water quality testing or someone who had experience with water quality or laboratory testing. And we gave them samples that we had spiked with either concentration of atrazine, nitrate, or phosphate. And in a second set of studies, we went out and collected water samples from a local creek. And again, we had citizen scientists that we grouped as either inexperienced, meaning they had really no prior experience with laboratory work or collecting water quality data. Experienced were students who had taken a laboratory class or had some experience with working in a laboratory with water testing. And then our expert testers were individuals who worked at their job in some type of laboratory setting and were very experienced with conducting laboratory tests. And so I'm just going to show you one piece of information, but just to explain what you're looking at. What we use to determine how accurate citizen scientists could be in collecting water quality and analyzing water quality data was something called a receiver operating curve. And so a receiver operating curve really plots sensitivity, which is the probability that a citizen scientist would have reported an accurate and correct measurement. That's on the y-axis. Versus specificity, which is the probability of a false positive. And so, for example, our sensitivity here, our true positives in this little graphic would be telling a pregnant woman, you're pregnant, right? Your test came back to be positive. Our false positive is telling this poor gentleman here that his test came back that he was pregnant. And so if you have basically the accuracy of a coin flip, a 50-50 accuracy, that would follow this one-to-one line. And then you can, from the area under the curve of these receiver operating curves, it tells you something about the accuracy with a perfectly accurate test, basically following this y-axis up to 1 and then plateauing across the x-axis. So here's some data that we generated from our test for nitrate that we use in our citizen science program, which is just a colorimetric test strip that probably many of you are familiar with, where you place the strip into your water sample, wait for about 1 minute, and then you read it against a color chart. And what we found was that our expert testers were very, very accurate with that particular test. And they were able to accurately measure the concentration of nitrate within their water sample. Our experienced testers, so again, these were a group of people that had some prior experience, were also fairly accurate, with the area under the curve being 0.78 compared to 0.92 for the expert testers. Interestingly, our inexperienced testers were actually less accurate than a coin flip. I think that this is probably due to the fact that for our field collected measurements, we had a lot of zeros or non-detect concentrations. And when you hand someone a sample and a test and ask them to test for a specific compound, they're not as comfortable reporting a 0 value. And so I think that led many of the inexperienced testers to overestimate their concentration or report a positive value in the sample when really it should have been reported as a 0. Nevertheless, what we find though is that there's a progression with experience. So if someone is trained and routinely completes this testing with training by someone who's more experienced, they can move up from an inexperienced tester to a more accurate tester and really achieve good accuracy with these tools. So that leads us into our citizen science program, which I'll just talk about for a few minutes. So we started our program in 2018, wanting to measure nitrate concentrations, and we also measured phosphate concentrations in both private wells and surface water in eastern Nebraska. From 2018 to the present, we've had over 600 volunteers collect over 900 surface water samples and over 680 groundwater samples. We run the program on a seasonal basis, both spring and fall, and we recruit our volunteers through a website. The website link is given here, where they can sign up for the program and volunteer to test. So with citizen science, a lot of focus is on recruitment and management of volunteers. So I just wanted to talk a little bit about that. In 2018, when we started, we didn't do a lot of recruitment, and then we made a very significant push for recruitment in 2019. A lot of social media events, as well as some radio and television interviews that we did, as well as outreach at different conferences and a fair that was through our educational television event. And so as you can see, if you look at the blue line, which is our volunteers, we started kind of modestly. And then once we started really recruiting, we had a huge number of volunteers throughout 2019. And then of course, in 2020, we had the impact of COVID on our project. We actually canceled our spring 2020 sampling because of COVID. However, we did have a different organization called Conservation Nebraska, who had volunteers out in the fields. They had a focus on water quality. And so we had about 8 individuals go out and collect water quality samples for us. So we were still able to run the program. And then you can see we're starting to see a bounce back in our volunteers in summer of 2020. And then I'm still compiling the data for spring of 2021. So again, we run this program seasonally. The first year we ran 3 cycles of spring, which was really about May, summer, which was late August, and then fall was October. We saw kind of this drop off in the October participation. So from then on, we just decided to run a spring and summer program. Before I show the data, it's also important to talk a little bit about what happened in Nebraska in the spring of 2019, because I think our citizen science data tells a kind of interesting story about maybe some of the water quality impacts of this flooding. And I think it also highlights one of our hypotheses that you can see different types of information with citizen scientist testing that might otherwise be really hard to collect. So in the spring of 2019, we had a very catastrophic flooding events in Nebraska. This is just a picture showing, this, the Missouri River and its natural channel versus the flooded version in the spring. And really what happened is that we had very frozen soils in March of 2019, a lot of warm rain. It kind of warmed up. So the air temperature was really warm. And just over a couple of days, a large amount of rain fell on completely frozen ground, and all of that water ran off and flooded a lot of areas in eastern and central Nebraska. So getting to our citizen science data, the reason I pointed that out to you is because I think we see some interesting things in our data when we start to look across the 2018 period and compare that with spring of 2019. So this would have been May following that March flooding, and then our summer of 2019. And so this is nitrate concentrations in groundwater across eastern and central Nebraska. If you look kind of through time, in 2018, we had just over 50% of our wells registering a nitrate concentration less than 2 parts per million, meaning that the rest of this bar represents wells that had nitrate at either 2 parts per million, which is the yellow, 5, and then the red and dark red correspond to concentrations at 10 or 20 parts per million, which would exceed the drinking water standard. What we found that was interesting was that when we looked in spring of 2019, a couple of months after these flooding events, we actually see more nitrate in groundwater, which could correspond to that flood waters eventually infiltrating and impacting the nitrate that was being held in the soil and carrying that down toward groundwater. So in spring of 2019, we had just under 30% of our wells, so a 20% decrease in wells that were less than 2 parts per million. And then it kind of bounced back in summer of 2019. Another way that we characterized our data was just looking at the percentage of our wells that exceeded the drinking water standard for nitrate. It kind of bounced around a bit. In 2018, we had fewer data. It was about 30% of our wells. In spring, it was again about 25. And then in the summer of 2019, it was only 13% of the wells. But when you average those, you get about 20%. And that's fairly consistent with what the state reports for the number of wells in Nebraska that exceed that drinking water standard of 10 parts per million. When we looked at our surface water data, we saw also potentially a story that could be related to some of the flooding effects, whereas we saw, again, now surface water samples, only about 35% of our samples had nitrate below 2 parts per million in 2018. But we saw that surface water, actually nitrate concentrations declined or improved with a greater percentage at less than 2 parts per million. And again, is that possibly an effect of dilution from that rainwater and floodwater that occurred during that period? And so again, it's we're not certain if that's the effect, but certainly by activating people to measure water quality across the state right after this flooding event, it seems that we maybe captured what was happening in kind of this larger geography, which would be really difficult to capture with existing monitoring programs. And then for phosphate and surface water, again, we overall saw some declines in phosphate in surface water from 2018 and then across the period in 2019. So what did we learn from citizen science? First, we learned that with training, citizen scientists can accurately collect water quality data. I think this is really important because this turns citizen science not just into an educational program, but also a scientific tool. It's not high quality information. It's not equivalent to analytical testing, but it's a different type of data that can be used in some specific ways. What we also learned from our citizen scientists is that about 20% of our wells exceeded the nitrate drinking water standard of 10 milligrams per liter. This, of course, relates back to our work linking nitrate and health impacts. And so we know that groundwater in Nebraska is impacted by nitrate. And over half the wells had nitrate concentrations greater than 2 milligrams per liter, with some papers focusing on health impacts of nitrate, noting there's potential for some health impacts, especially in children, at concentrations lower than the drinking water standard. And then interestingly, did we see evidence of the impact of flooding on water quality? Possibly, due to our citizen science network. And again, I think that's something that we would not have been able to see if we used a different type of testing tool. So with that, I'm happy to acknowledge and thank all of my many collaborators. And I'll highlight, of course, Dr. Alan Kolak, who's one of the seminar speakers, as well as Jessie Bell. I also want to specifically highlight Ipsita Nandi, who was one of the WaARISH scholars. And with acknowledgement of our funding sources, I'll be happy to answer any questions.
Thank you, Professor Shannon, for your wonderful keynote lecture. And I request the participants to come up with any questions. You can type them in the question and answer chat box. You can accommodate 1 or 2 questions. Professor Shannon, from this lecture, I feel that although, as you said, that citizen science data, that means the collected from the student volunteers, may not be accurate, but I think this will help us in identifying the hotspots of the contaminants transports in the, especially in the groundwater system, because that's what is a key issue that we focus, because suddenly we find this kind of issues. Okay, I have a question from Dr. Soumik Goswami. A brilliant correlation between water quality and diseases. We can also focus on light as a reason for cancer, artificial light at night. So this is this question.
Yes, yeah, thank you for that question. It's a little outside of my area of expertise. They don't focus as much on light pollution. I focused more on water quality, but I think it just highlights that there can be many causes for health impacts related to environmental issues and environmental exposures, and it's really important to look at both, genetic causes of disease as well as environmental causes.
Okay, Professor, I have one question with the continuation with my understanding of your study. You have mentioned that the groundwater showed more concentration of nitrate after flooding, and but surface water showed dilution factors, and in summer again your groundwater started diluting. So is it maybe the initial infiltration samples have more amount of nitrate leached in, and then the flood water, which is again getting infiltrated, may have less amount of nitrate, which shows dilution in groundwater also? Is there a chance that we have?
Yeah, I think that's possible. And I have to say, we really didn't set out to try and specifically answer the question of what the impact of flooding was on water quality using citizen science. But I think it's an interesting illustration for the types of questions I think could be answered and that we hypothesize could be answered. And it's also a great example of how you could use citizen science data to maybe form a working hypothesis that then you could go back and test with more precise analytical approaches.
Okay, thank you. So if you don't have any questions, okay, if you have any questions, you can address and you can chat. So we will try to get the response from Dr. Shannon later.
Yeah.
Thank you, Professor Shannon. With this
Thank you very much.
thank you. So with this keynote lecture, our inaugural session comes to an end, and let me go to the today's session of keynote lectures and the lectures or by the young scientists. So to start with, our next or our presenter today now is Dr. Jay Gann. Dr. Jay Gann is a professor of environmental chemistry in the Department of Environmental Sciences at UC Riverside. He is fellow of the American Society of Agronomy, American Association for the Advancement of Science, Soil Science Society of America, and American Chemical Society Agro Division. Professor Gann is co-editor-in-chief for Science of the Total Environment Journal. Professor Gann is the co-author of over 300 peer-reviewed journal articles, 5 edited books, and about 30 book chapters. I welcome Professor Gann, and I request you to take over the proceedings.
Okay, thank you for the kind introduction. Let me share my screen. Okay, let me go to the
It's not from
slide.
the beginning.
Let me do it over again. Sorry about that. Okay, I think, let me try again. Is this okay?
Yes, sir. Yeah.
Okay. Well, first of all, thank you for involving me in this workshop. I got the invitation about a month ago, and just so happened that I know both of the conveners. Thank you, Peru, and thank you, Dan, for inviting me. My name is Jay Gann. The presentation I'm going to give over the next 20 minutes or so is about emerging contaminants. That's my area of research. So I'm going to focus on emerging contaminants in agro-food systems in the context of water reuse, and also in the context of like biosolids application. This, of course, has been going on for quite a few years in my group. I would say about 10, 15 years. So I have a lot of people contributing to this research. So before I start, I want to, just for the benefit of some of our students in the audience, I'd like to give this little background about University of California, Riverside, University of California. As you know, University of California is not a single university. It's made of 10 different campuses. And most of these universities, most of the campuses are luckily on the coast of the Pacific Ocean, right, West Coast. So you may have heard many of them, I guess, UC Berkeley, UCLA, UC Irvine, UC Santa Barbara. And also we have a few university campuses on like inside, like inland of the coast. That includes my university, the campus, UC Riverside. We are about 50 miles, about 80 kilometers inland from the coast, from Los Angeles. And in terms of environmental research, I want to say that for engineering, Berkeley, especially UCLA, UCSB, and also UC Irvine, they are doing a lot of work on water treatment. They're very good in terms of engineering, as well as UC Davis. In terms of whole comprehensive environmental research, I would say UC Davis and UC Riverside are very well known for research on soil science, just the water quality. And UC Riverside actually is very well known for air pollution research. The reason is because Los Angeles, as you know, 30, 40 years ago was a highly polluted area. And because of that, the air pollution research at UC Riverside is really, really first class. So just give you an idea about these 10 different campuses. And each campus is basically a university by itself in terms of research strengths and also in terms of just the governing of the each campus. And the reason we're good in terms of environmental research or agricultural soil science research is because California, as you know, there's a Central Valley, and that is very well known for agricultural production. And of course, California is well known for IT, very well known for making films, making movies, but also agriculture in California is hugely important, especially for some cash crops. And California also, agriculture is different in the sense that it's irrigation agriculture. And because of that, there's a lot of research happening over the many, many years. And this is my campus. We have a tower, it's called a bell tower. I hope some of you will get a chance to visit us in the future. So my talk today is focused on wastewater in the context of water reuse. And specifically, we're going to talk about emerging contaminants in the sense of contaminant transfer from soil, well, from water, biosolids to soil, to plants, and potentially to humans. And I'm going to basically provide two approaches. Some of this we have been working on, some is just my wishful thinking. I think it's something that people should do for this kind of research. So as we know, emerging contaminants or CECs, we're going to use CECs here. Basically, they include a lot of chemicals like pharmaceuticals and personal care products, or PPCPs, not only human pharmaceuticals, but also pharmaceuticals like antibiotics we use on animals. And also we have some so-called new POPs, new persistent organic pollutants like flame retardants. And nowadays PFAS, as we know, they are hugely important nowadays. And also, of course, a lot of research is happening on microplastics, and as well as the chemicals from the plastics. They're called plasticizers. Of course, nanomaterials. So those are most of these are what we call emerging contaminants. And basically, they're the contaminants that EPA does not have limits, unlike, for example, nitrate. So this, as we know, there are a lot of these chemicals, and humans are very good at making new chemicals. We are making basically one new chemical every 5 seconds. And a lot of these chemicals are used basically for our daily life. And when that happens, as we know, that they go, for example, a lot of the chemicals we use, they can go into wastewater treatment plants through our sewer system. So they can appear in the recycled water. They can also, for example, appear in like produced water, especially nowadays. For example, shale gas is becoming very important. You can imagine that we use a lot of chemicals to produce shale gas. And so the water we have also contain a lot of these chemicals. And also in places like that are really dry, people are increasingly using like stormwater, also try to reuse like tailwater and other type of just the poor quality of water. Especially I have this map here just from yesterday. I took this map. This is showing like the drought status of US. You can see the west half of US is really dry these days. You may have heard that California, basically we're in the middle of a water crisis. We have a mega drought. So because of that, you can imagine that the use of this so-called lower quality water is becoming hugely important. And where is a better place than agriculture, right? That's where really, I think the future of the water reuse is just to use this water for irrigation. Along the same line, also, as we know, we use biosolids. Instead of put biosolids in landfill, we can make use of biosolids because they contain a lot of nutrients, animal wastes as well, and so on and so forth. But when we try to use these so-called wastes or waste resources, one concern, of course, is we have a lot of other things, right? We have metals, we have a lot of other chemicals, salts, for example, pathogens, but also nowadays, more and more importantly, people realize we have a lot of so-called CECs. So when we use the treated wastewater or biosolids in agricultural fields, these chemicals will enter agricultural food systems, and potentially plants can accumulate these chemicals. And if humans consume these chemicals, these food products, then potentially humans can be exposed just incidentally to these so-called CECs. So this is my line of reasoning, and that's the reason we're doing this kind of research. And there are multiple groups in the world that are working on this. We're one of them, and but the problem with CEC is, as I just showed you, we have so many of them, and as I mentioned, very likely we're over 100,000 different kinds. We're still making more, and they're very different chemicals. They have very diverse chemical structures, and their properties are very different. Normally, the levels are very low. Just to be frank, the levels going into the soil or agricultural fields are very low. However, if you keep putting this out there, like irrigation, then these chemicals can become sort of pseudo-persistent contaminants. We have been working on this for about 15 years now. My sense, to summarize the situation of this, is I think that current research on so-called emerging contaminants overall is very scattered. There's very little logic, basically. And a lot of people work on this, myself included. It's because we're working on newer chemicals, it's easier to publish papers. So really, I'm trying to make a pledge here is we need to do better, more organized, collaborative research so we can really get something that's meaningful. So again, the focus of this talk is to look at how chemicals can go from wastewater to soil, or from biosolids to soil, then from soil to plants, and eventually to causing human exposure. But as you know, chemicals like nutrients, they can undergo many different processes before they can really accumulate in the edible tissue. For example, we have a tomato plant here. The chemicals have to go through sorption transformation in the soil first. Then they'll get a chance to get into the roots. And once they get into the roots, they have to be able to translocate. A lot of chemicals cannot do that. And then eventually they get into the plants, and then plants, as we know, we have a lot of enzymes, and these chemicals can become metabolized. And eventually the chemicals that cannot be metabolized, if they have a tendency to accumulate in the fruits, that's where I think the real concern is. When humans consume, for example, the fruits, that's where the exposure can happen. So there are a lot of layers, a lot of processes happening along the way. And that's what we try to understand. And this, when it's coupled with the numerous numbers of CECs, you can imagine it's becoming a real dilemma. It's just a very hard try to understand this by doing research. So here I'm proposing two approaches, just summarizing what people have been doing and what also we have been trying to do. One is called a top-down tiered approach. I just showed you that chemicals have to go through the roots, go through the plants, then they can accumulate eventually in the edible tissue, then that can cause human exposure through dietary uptakes, for example, or dietary intakes. So we can use some of the simple, the top process, for example, try to really identify so-called high-risk chemicals. We have so many chemicals, not all the chemicals will present a problem. Maybe 99% of the chemicals will not be a problem. But it's important for us to know the 1%. And how do we do that? And here is just a top-down approach, because we said, looking at the previous slide, plants can metabolize these chemicals, even they get into the plants, because plants have a lot of enzymes. One thing we can do, for example, is to use cell cultures or plant callus tissue, for example. We try to use that as a high throughput screening technique. If we find chemicals can quickly be metabolized, then most likely they will not present any problem. But if we have chemicals that are very stable, and those are the chemicals we need to focus on. So that's something we have done. Other people also have done, is to use basically plant callus tissue or plant cells, because you use a small amount of chemical, so you can get results in a few weeks, and also in a relatively inexpensive way. And this just shows you we used the callus tissue from a cucumber, for example. Here, just show you some example. We have two sets of so-called CECs. And these chemicals, you can see the half-lives are very, very short in this system. We're talking about hours. Even these chemicals, they get into these plants, very unlikely they're going to survive. So by the time humans consume the fruits or the leaves, these chemicals would be gone. On the other hand, some of these chemicals, they're relatively more resistant. And if we follow this logic, then ideally we should only focus on these chemicals that are resistant to metabolism. That's a tier one. That's when I say from top down. That's a top tier. It's good. We can identify the potentially high risk chemicals. And once we have a short list, then we can do something that's more extensive, more expensive as well. For example, we can use so-called hydroponic cultivation. I'm sure everybody knows. Basically, you grow these plants in nutrient solution, you spike chemicals. Then you can understand which chemicals will get into the edible tissues. Like in this case, we have spinach and some of the cucumbers and things. Because they're nutrient solution, it's relatively to control, relatively easy to maintain. And also the turnover also is relatively short. We're talking about maybe a few weeks or maybe a few months. You use greenhouse or growth chambers. So this will give us more improved knowledge about the potential accumulation. For example, in this case, we had about 20 chemicals. And if you look at this, only 3 of the chemicals had appreciable accumulation in roots or in the leaves. most of the other chemicals, they simply do not go into the plants. So knowing this is very powerful because then we can move on. We can spend more money, for example, or spend more manpower, pay more attention to those chemicals, these chemicals that can have a high potential for accumulation into the food organ. Then tier 3, that's the last option, is once we know the real potential high risk chemicals, then we can do monitoring, or we can do field experiments. And that's something we did some years ago. And basically we mimicked wastewater irrigation. We focused on about 20 chemicals. And we analyzed, we grow these vegetables for the whole season. We basically harvested the edible portions of the vegetables at the end. We monitored for these emerging contaminants. And what we saw is only some of the chemicals we were able to detect, like some of these chemicals. And also most of the chemicals we did not see, or even when we saw them, the concentrations were very, very low. So this will give us, of course, more confidence when we communicate this to our public, to our consumers. We can say these are chemicals we should pay attention, but most of the chemicals should not be a concern. But doing field experiments are very expensive and takes a long time. So by using this approach, we know what to focus on. So that's why we call this a tiered approach. This is from top down. And this, again, showing some of the results. One thing we did find is if you use this water to irrigate your vegetables, and interestingly, like if you eat the fruits, for example, tomato, bell pepper, or cucumber, the accumulations are very, very low. On the other hand, if you have like root vegetables like carrot, the levels are relatively high, and the stem or leafy vegetables are somewhere in between. So this paper was published in ESNT because it's one of the field studies on this topic. So this got a lot of citations. The second approach I want to propose here is called process-driven. So again, we're looking at the same diagram. We have water, we have biosolids going to the soil, and these chemicals will have to go through many processes before they can accumulate in the edible tissues. And if we understand this chemical fluxes along these different processes, since we have done a lot of research on pesticides and nutrients, we have a lot of knowledge already. If we can combine this with these CECs, if we know the consumption, if we use some of the existing data, we can pretty much model under what conditions chemicals can get into the edible tissues. I'm not going to go into the details. It's a new grant we got from USDA. Basically, the logic is very simple. You follow the chemicals through these different processes, and then we try to answer the question, will the chemical really be able to accumulate in the edible tissues, like in leaf, in the fruits? And we know the physical chemical properties of these chemicals. We know their occurrence, their levels. And by doing this process-based modeling, we can roughly predict the potential risk. So this is what we call bottom-up or process-driven approach. I think this is more logical because you don't have to do more experiments, and you can basically harvesting or mining data using our existing knowledge. So again, same idea here. First of all, we want to know what chemicals are really going into the soil. And once they are in the soil, are they going to be able to stay in the soil? And can they go into the roots? If no, forget it. If they can go into the roots, then we focus on those chemicals. Then once they are in the roots, can they really translocate from the roots to the leaves, for example? or can they quickly become metabolized? Eventually, we'll answer the question, can they really accumulate in the edible tissues? So this is, I think, it's a much more economical, also a much more logical approach. I think this, again, it's called a process-driven approach. That's something we're working on, something also other people are working on. So we have published a feature article in ESMT in 2019, and you can look for more information here for our line of thinking. So now, just a couple more slides. I want to touch upon, in areas where you have to use treated wastewater or biosolids, sometimes because we need water, in most cases, also because we generate a lot of wastewater, we have to get rid of this water, right? In China, in India, in many areas we know we do not really need that excess water, but you still have to get rid of the water, right? So in China, I know wastewater irrigation is very common in many areas, just because, right? So here I'm talking about two potential options we can try to use. That's something we have not done research on, but I think just two good ideas, I think. One is, for example, not all crops are the same, right? From what we know, very likely like the fruit trees, like peaches, apples, or citrus, for example, very likely if you irrigate with wastewater, very unlikely the CECs will accumulate in the fruits to the same level as they would to some of the vegetables, for example. This is something we have to determine. Once we know, then we can really, I think, really promote the safe reuse of this by pairing the recycled water irrigation with the right kind of crops. I think that's a simple idea. I think everybody probably tend to agree here. The second option, again, something we have not tested, but I think it's logical. For example, as we mentioned, that plants, they can metabolize CECs, many other chemicals, right? They have a lot of enzymes because they want to detoxify these chemicals. These are xenobiotics. So if we have a long interval between the application of biosolids, between the application of treated wastewater, till when the edible tissue is harvested for human consumption, then the risk will be reduced. So the idea here is maybe we can use recycled water irrigation only for the first half of the growing season. Once, for example, the flowers start appear, we can stop. We can use some other good water, the conventional water. In that case, you have metabolism, you also have growth dilution, and very likely that'll help you to reduce the accumulation in the fruits, in the edible tissues. So those are the two ideas we have. And we have submitted a new proposal. Hopefully we'll get funded and then we can work on this. So to summarize, CECs, the dilemma is there's too many. And most likely 99% of them are not a problem, but we need to find the 1%, right? We need to have a short list. And I mentioned there are two approaches people are using. One is top-down. One is, I think, more based on models. Process-driven, I think this is more promising. It's something I hope more work can go into. And I also just mentioned that two practical practices we can use, basically fit for purpose kind of crop pairing. The other one is we can alternate between recycled water and fresh water for irrigation. What I have said here is concerned basically with recycled water, always biosolids with CECs, but I think the same approaches should be equally applicable to other scenarios. For example, we pay a lot of attention to antibiotics, right? Nowadays, I think there are a lot of antibiotics, there are a lot of antibiotic resistant genes. My understanding is not all antibiotic resistant genes are problematic, only maybe a few of them. So it's important that we invest our dollars, invest our resources wisely. Same thing can be said for nanoparticles, Same thing also can be said for microplastics. Maybe only a few types of microplastics are bad, but most of the microplastics, maybe they're just like clay particles. So that's my message here. And again, the work has been made possible by funding from many different sources and also from my hardworking students and postdocs. Thank you very much.
Thank you, Professor Gan. It was a very informative and more thought-provoking lecture that we had. Actually, it will be very useful for the young scientists or young researchers to learn how to approach a specific topic, especially in terms of present-day scenarios like CECs or microplastics or other things, and how we can also work on the societal benefits also. So with this, I request the participants come up with some questions. We can, yeah. You can type your questions in the chat box or in question and answer.
Yes, dear Professor Jain, myself from chemical engineering department. I have a general, am I audible? I have
Yes, sir,
general, I have a general question. Nowadays, especially with nowadays in India, for agriculture purpose, earlier some 25 years before and all, they use surface water from the rivers or ponds like that for agriculture purpose. Nowadays, most of the parts of India, because of shortfall of rainfall, storage of waters in ponds and rivers, most of the agriculture is being done with respect to deep wells as well as the bore wells. So they dig the earth for 100 feet, 200 feet like a thing, and they do the cultivation. Is there any difference between the chemicals that accumulates in the water with respect to the surface water and the deep borewell water?
Okay, that's a good question. That's a fundamental question for chemical fate and transport. My answer is, of course, there will be huge differences in terms of the kinds of chemicals you can find in surface water and the kinds of chemicals you find in deep groundwater. Because for chemicals to go into the groundwater, they have to go through a layer of soil. And Dr. C. Ray is an expert in this. That's basically the realm of soil physics. We talk about chemical transport. And when chemicals, they have absorption to soil, very likely these chemicals will never appear in groundwater. But on the other hand, some of these chemicals, they will appear in the surface water. So I would say the levels, the types of chemicals could be very different.
Thank you.
Thank you.
Okay. Thank you, Professor Gan, for your wonderful lecture. And we will have a short break and we will resume the session at 10 o'clock IST. We will have a 15 minutes break.
Thank you very much.
Thanks. Welcome back. Good morning, sir. Good morning, Professor Tripathi.
Good morning.
Welcome back. So we will continue with our keynote lecture session. Now the keynote speaker is Professor S.N. Tripathi. Dr. Sachidanand Tripathi is a high administrative grade senior professor and head of the Department of Civil Engineering at IIT Kanpur. He is the recipient of Shantishwarup Bhatnagar Award and J.C. Bose National Fellowship. He holds the Arjun Dev Joneja Chair at IIT Kanpur and elected Fellow of the Indian National Science Academy, Indian National Academy of Engineering, National Academy of Science of India. He has made impactful contribution to address challenges of air pollution and climate. Now I request Professor Tripathi to take over the session.
Thank you. Thank you very much. I should just clarify that I'm no longer HOD. Somebody else is taking over. It's a privilege to be here, and I see that conference is very well organized. So I believe you have enabled sharing for me, so I can go ahead and share my slide.
Yes, sir. It's enabled.
Yeah. So you can see my slides, and you can hear me, so I can start the talk, right? You can see the slide?
Yes, sir. We can hear you and see the slide.
Thank you very much. And you can probably, alert me a couple of minutes before, 30 or whatever time limit you have set in. So, good morning, everyone. I'm Sachi Tripathi at IIT Kanpur, and I'm going to discuss some of new monitoring technologies which we are trying in this country to support National Clean Air Program. Some of you may be aware with National Clean Air Program, which is also called as NCAP, and currently is being run as a mission mode by the nodal Ministry of Environment, Forest and Climate Change of Government of India, was launched in 2019 with a goal to cut down PM 2.5 by 25 to 30% by 2024. So in 5 years, they have a target to reduce main pollutant PM 2.5 by 1/3. And the program actually rests on 3 pillars, mainly data and science. And second is institution and capacity building. And third is mitigation of pollution across across all the major economic sectors. So we have been working very closely with National Clean Air Program here at IIT Kanpur. We are certainly contributing towards generating more data, and some of the work which I'm going to show actually contributes towards that end. And in the second vertical, that is institution and capacity building, we also have built an alliance of higher academic institutions, mainly technical institutions like IITs and ITs and government labs across the country, with an idea that these institutes can support implementation of Clean Air Program across the 130 non-attainment cities, the cities which currently do not meet the national standard. And that Rainbow Alliance, if you may, is recognized by government, and it's called Knowledge Network to support National Clean Air Program. So let me begin with acknowledging a couple of major funding agencies, including CPCB, Department of Science and Technology, Department of Biotechnology, Ministry of Earth Sciences, and MOEFCC, who have very generously supported some of the work I'm going to show in today's presentation. And I also thankfully acknowledge contributions made by past and present PhD students, postdocs, other project staff, and some of the work I show here was done in collaboration with other partners from the country and some partners from abroad. So I cannot name them all, but I gratefully acknowledge their contributions as well. Since we have, I believe, an audience drawn from both water, air, and probably other disciplines as well. So I thought it would be good to give a very quick primer about how aerosols are generated, how they stay or travel in the atmosphere, and what is their fate, how they get transformed and get removed from the atmosphere. So what you see here in this slide on the x-axis, you have three different kind of source. You have anthropogenic, rural, and biogenic source. And you have a variety of pollution that comes out, which could be gases, and it also could be primary particle. So there is a difference between primary and secondary. If the particles are generated or emitted directly from source, they are primary, otherwise they are secondary. If they are formed in the atmosphere from the precursors gases. So in this case, what you see that some of these gases are precursors to secondary organic aerosol, and secondary organic aerosol has been quite a focus of investigations for last a decade or so, because in different settings, they can contribute as much as 50 to 70% of total PM 2.5. And that is what has been a major concern in the country, in India. What you also see here on the y-axis is basically giving an idea, and during the residence time in the atmosphere from emission, how do they get transformed into different kind of pollutants through chemical aging, growth, etc. And then finally, there could also be cloud and other kind of processing that could happen, and that may lead to removal of particulate matter from atmosphere. So coming back to this chart again here, what you see, secondary organic aerosol can be in the semi-solid phase, or it can be in the liquid phase. And then it can certainly also have a feedback into climate, as you see, via directly interacting with the radiation. And that is what we call as the first direct effect. And it can also act as a CCN on which cloud droplet form. And through that, it can modify cloud properties. Cloud can become more reflecting, and that can again act as a forcing on the earth energy balance. So you see that we are not only concerned about air pollution here, we also see that aerosols interact in a major way with climate as well. And that is why it's quite important to understand these aerosols from a variety of regions. And we are basically discussing here that how we are going to monitor them from the air pollution perspective. This is a work which was done a couple of years back, which just shows that what is the overall mortality, what's the people's death across the globe because of PM 2.5. And what you see on the left, you have here the red spots are mostly lying in part of India, and in India also in Gangetic Plain, you see that there are clear red spots, and then there are some yellow spots which are going all the way on the western coast, basically in the major western cities. And then there are some red spots which are also there in China. And scale, you see that as you move from light to dark colors, it shows that the mortality increases. And on the right, these mortality is linked with the type of pollution, and mainly the work done here in this paper was mainly on PM 2.5 related mortality. Okay, so what you see here, there are different kind of sources, but over India, it shows that primary source is residential cooking. You see RCO. So these are mainly related to people who use solid fuel. And that has been shown now that a good part of PM 2.5 is because of the primary and as well as gaseous emissions coming from solid fuel and other kind of fuel which is used for cooking, heating, space heating, etc. And that leads to eventually formation of secondary or other kind of particles which we see in the ambient atmosphere. So let me first start with work which we have been doing, and this is quite, I would say, relevant here because this workshop is supported by IOSSTF. So we have been supported by IOSSTF, that is basically IOSSTF, Intel and DST. They have come together to support this work about sensor-based monitoring And in this work, this is basically an overview slide, which shows on the left that we have tried different kind of network, which is going from 2G, 3G, 4G. And in different settings, we are also trying NB-IoT, which is narrow bandwidth Internet of Things, because once you sense the data, it's important that how do you transmit the data, how effectively you transmit the data without compromising with the power consumption and bandwidth, etc., etc. And you see, we also have tried a very interesting technology that is called 6LoWPAN, that is on the bottom left, which is ideal for campus-like setting. For example, in your university or IT Kanpur campus, you can use this where you are not required to rely a lot on internet. Rather, you just need some internet points, and in between you can use other communicating points, which are called router and other stuff, and gateway. And through that, you can finally transmit the data to the cloud server. So that is what is shown here, is that all the data through that comes. And then we have actually worked out quite a few calibration protocol. And some of these calibration models are running on the cloud. And then you can get the data, which is the calibrated data, out using machine learning tools. And finally, this data can be accessed through APIs. So anybody can take the data and then they can use it. As of now, we are running as part of this project a successfully operated network in the campus, and we are also running a couple of networks in other cities which are supported by some other partners, industrial partners. This is what one work we did as part of this project here, which is what you see that in this plot is mainly the reference grid monitor data, which is from EBAM. This device is generally used by regulators. So this is equivalent reference grade monitor. It gives you highly accurate information about PM 2.5. And on the y-axis, we have PM 2.5 measured by relatively or much low cost sensor compared to the BAM. And what you see that we found that linear regression model can give you a very good relationship between these two. And if you apply a couple of corrections related to temperature and relative humidity, you can get a very high R square and relatively low error. So you see R square can be as high as 0.9 in different settings. So this work actually has been now used by US EPA, and many other people are using this work. Has been quite well received, where that need for understanding the accuracy of PM 2.5 sensors are required, and this is one of first work in that direction. This is a follow-up work where what is done here is that very unique machine learning model has been tried, Gaussian progress regression. And idea here was that how one could calibrate the sensor without having the need for co-location, because earlier work was done where sensors were placed next to a BAM, and then you try to take both data and then you find out a relationship between both of them. Now, for a real-time condition, it's difficult to always co-locate the sensors to BAM. If you're running a large network of 100 or 200 sensors, then it becomes very difficult for them to always bring it to next to the BAM and try to get a relationship, because then you are basically disrupting the network in some way. So idea here is that if you have a government run or some other network that is already in place in the city or wherever you want to deploy or run a sensor-based network, that data, that already existing reference grade monitoring sensors or monitor network data, you can take that and then try to work out an algorithm where that is what exactly has been done here, that you try to work out an iterative algorithm through which you correct the sensors data. And In this way, basically, you are not required to always co-locate the sensors next to a BAM. And that is what has been done here. And now, currently, in fact, we are further working on that so that eventually the model which has been developed for the co-located sensor and BAM, which was shown in the earlier slide, if you have different models available for different co-location studies, you can stretch it and then try to develop some kind of adaptive model. I will show some results on in the next slides. This is similar work, but of course done on the gas sensors. And what you see here is basically calibration applied on NOx sensors on the left and ozone sensors on the right. Again, in this case, we had used reference grade analyzers for which gives you very accurate measurements of NOx. And you also have the data which is available from the low cost sensors. And we found that for different conditions, like in Delhi and Mumbai, we found very good performance where R square could go up to 0.8 in case of NOx, and it can go up to 0.9 for ozone. And now we are also working on this, that how we could in fact improve the accuracy of these sensors by adding more data into the calibration model. And that is what currently is a work in progress. This is again calibration done on PM10. Earlier was what was shown for PM 2.5. And you know, in India, the National Air Quality Standard has several criteria pollutant which they try to monitor, and NOx, ozone are gas ones. And then for PM, they monitor both PM 2.5 and PM10. And what is shown here is how well PM10 can be measured using sensors. And in this case, where the co-location was going on, we did not have a reference grade PM10 inlet in the BAM we had here because we were running it for PM 2.5. So the reference data we used was from scanning mobility particle sizer and optical particle sizer. So these are very much research grade instruments, which gives you particle mass concentration and as well as number for very small from submicron and supermicron particles. And if you can synthesize them, you can get complete PM10 information. And that was basically that synthetic PM10. Synthetic means that, of course, measure, but then using the measurement from two sets of instruments. And then we found that even in case of PM10, you can get an accuracy of up to 0.75, which is quite, I would say, encouraging. This is now looking into the success of some of these work. Maharashtra Pollution Control Board has approached us to evaluate sensors accuracy using their network in the city of Mumbai. So what you see here, these are some of the representative sites. Out of actually 15 sites where sensors were deployed, they have a network of 15 stations across Mumbai. And these are some of them where sensors were deployed. And in this experiment, 4 leading startups from the country who are very active in this area, they participated. Okay. So basically in this case, for every station, you see there was a reference grade monitor and 4 startups, each of them deployed the sensors. And this experiment was run from 1st of November till end of May. And this is some of the results which is already communicated. One of them actually has got some nice review. It's resubmitted, you see on the bottom, and another is also submitted for publication in a conference. So if you look at the top figure, you see there are 4 sensors, so we call them startup A, B, C, and D. And if you look on the top left plot, you applying the co-located data set, using the co-located data set and the calibration model which was developed from that, you could we could bring the error down to 15 to 20%. Okay, except for one startup, the error generally was around 15%, and R square was as high as 0.75. This was, and this result is based on about 40,000 hourly data points across 15 stations. So that's a very large data set which has entered into these computations. So the results are very, very robust. And as I was stating before, that then we try to extend this model for a location where reference grade monitor data is not available, okay? Or you had a very short time co-location. So you can imagine that when you are actually operating a network in the city, then it will be difficult for redeployment next to a BAM or reference grade monitor for a long time. At the most, you could redeploy or co-locate for frequent calibration for a day or 2 days. So what has been done here now, that once we have developed a model using a long period co-location, and then using that data, we try to import or port that model to a different location where you have a very short period data or co-located data is available. And that we call it now adopted model. So now what you see, even with the adopted model, it's exactly the same result what was shown in the top row is also shown in the bottom row here. With the adopted model, what you see is results are also quite convincing. And in this case, the co-location was only for a few days. So our next attempt would be to, as we have shown in the Gaussian progress regression, where a different way of developing the calibration was used through iteration and using interspersed network or data from a government run network. Here, idea is that you are using still the data from a single BAM, single station, but basically building on a model which has been developed using a very long period co-location and then porting it to a new location. So certainly there are different ways to develop these things, but idea is that you want to correct the sensor data frequently so that they give you reliable information and without disrupting the network's operation. That's the key aim for running these networks, which is what you are trying or getting it from the very high-end reference grade monitors, but which are very, very expensive. We are talking about a cost difference of factor of 50 to 100. So in one reference grade monitor, you can buy easily 100 sensors or about 70, 80 sensors. Now I'm slightly, shifting to another technology, which is basically understanding the sources of PM 2.5 in a relatively shorter time compared to the traditional technique. So as you have seen or you have realized that sensors can give you the measurement or amount of particulate matter which is present in the atmosphere. But if you want to mitigate them, then you have to understand or you have to find out the sources which contribute to ambient PM 2.5. Now, traditionally, people have been using a method which is collecting the particulate matter on filter and then storing them and then exposing them to different analytical techniques in the laboratory. And so entire process is cumbersome and it takes somewhere from at least 1 year to 2+ years before you get some information about the sources. In addition to that, you also have some biases. As I mentioned, secondary organic aerosol, the filter-based techniques have a very high negative bias. They tend to underestimate secondary organic aerosol, which is a very prominent constituent of PM 2.5, certainly in India and particularly in the Gangetic Plain. So this is the method. What we are doing here is that we are using a set of instruments that gives you real-time measurements of all constituents of PM 2.5. So it's a set of 3 instruments, and one of them a mass spectrometer, second is a metal detector, and third is a soot spectrometer. And all 3 together can provide you a real-time chemical speciation, complete chemical speciation of PM 2.5. And then using that, one can invert this information, again using different techniques, which are certainly mainly kind of inverting a large set of linear equations. And so we are using here an advanced version of positive matrix factorization. And then you can actually get different sources which are contributing to PM 2.5. That is what is shown here in this work. So you see that that's one advantage, is that this information can be available to you within few days or week of the measurements. So if you have started the measurements on day 1, and if you have about 5 to 7 days of data, you can start running this model, and you can have a very realistic and good information about sources which are contributing to PM 2.5. The reason is that, main reason here is that in the case of filter, you collect particulate matter on the filter for entire day or maybe twice a day. So the number of data point that is required to run these models take much longer period before you have a decent size of sample. Because generally people do it seasonal in analysis, because in a season you might have 70 to 100 data point. Now here in this case, because these are real-time measurements, and if you even average them every 15 minutes, still in a day you have about 100 data point. In 5 days you have 500 data point. So that is one advantage. Second, for organic aerosols, you can get a lot more information, and that quite a few chemical fingerprints about the sources come through organic aerosols. That's second. Third, the metal detector can give you from somewhere from 25 to 40 different metals. And each group of metal, not a single metal, but each particular group of metal can give you a unique information about source. So these 3 actually give an edge to what we call as the real-time source apportionment. So what you see here is that, for example, in Delhi.
So sorry for the interruption, sir. 5 minutes.
Thank you. So for example, here in this case, in Delhi, we got, for example, cooking organic aerosol. This has not been recognized in Delhi before. Why? Because unless you run a mass spectrometer, you would not be able to discern this source. Now, second thing, as I mentioned before, that the other techniques give you information, that source information for whole season. So you'll just get a single pie, that the pie is composed of these sources for an entire season, let's say winter or summer. What you notice here is that each source is given as a time series. So for any time, if you take a slice across all these rows, you can clearly work out how different sources are contributing for that particular time for that date. So you could also clearly understand that for an important pollution episode, how different sources are contributing, and that can definitely give you a lever, a handle to go in the field and do something about it, right? This is certainly another demonstration of the same technique, only applied for the organic aerosol. In the earlier one, actually that was used for both organic and metal or inorganic, everything clubbed together. Here is only done on organic because, as I said, organic form a very important constituent of entire PM 2.5. And here basically these have been dissolved into different sources. And some of them, for example, are local in nature, some could be urban, and some could be even regional in nature. And these all can be worked out by looking into the different kind of organic fingerprints which are there in the particulate matter. And these has been, all these sources, what we are getting here has been actually substantiated with external data set. And we find it that these are very robust factors. This shows another example here that using just the metal data, again, you are getting every half an hour real-time data. And if you club them with the wind information, so that can provide you very interesting information about where these sources are located, which is contributing to the PM 2.5 at the receptor side, which is shown by blue here. So for example, the receptor side is Delhi, and for different periods, what we see here is that there are 3 distinct clusters, cluster 1, cluster 2, and 3, which contributes to different type of PM 2.5 at the receptor site, which is IIT Delhi in the National Capital Region of Delhi. So that way you could see that, well, for this set of things are coming from, for example, here in the blue one, something is coming from close to Delhi from east, and in other one, it shows some time that is coming from maybe some other places, like from, we have seen that from the border of India and Nepal. So accordingly, mitigative actions can be taken. This is another example where basically data from 3 distinct cities, that is Beijing, a Polish city, and Delhi, has been shown here. And what you see that if you use 2 different parameters, one is the ratio of PM 2.5 to PM 10, which gives you relative contribution from anthropogenic sources to PM 2.5. And another is the enrichment factor that is shown on the y-axis, which shows what is the contribution from the earth crust. So that is actually shows what's the contribution from the natural sources. And you see that if you club all metal on these 2 axes, you would be able to group everything into 5 different categories of sources. And that is listed on the bottom of this slide. You see, across 3 cities, very different setting, different pollution load. And then finally, there are actually 5 groups, which gives you a very nice way to capture the source information in the cities. And then, of course, this information is available on a dial or diurnal basis. So we have seen that, for example, some metals contribute a lot in the early morning in Delhi. So therefore, one can also take actions to avoid impact on people's health. And finally, what I'm showing here is that the government wanted to have some information during COVID-induced lockdown last year. And you can imagine that when the lockdown is there, you wanted to have this information in a short time so that it can inform government that how the sources have changed. And definitely this would also give other information about background level of pollution, background sources, which are always there in the city of Delhi. And since we have the real-time system that time was operational in Delhi, we could provide what you see, the different pies are basically giving information for 4 different phases of lockdown for 3 major constituents of PM 2.5. And this information actually was used by Central Pollution Control Board in their report, which they published in September on the impact of lockdown on ambient air quality. Finally, we are also doing currently, we have just extended this work in the city of Lucknow, and that's still going on. And one final thing I just want to, I will stop it here, is that we also have used this data, which is currently a work in under review, where we could clearly distinguish between the biomass driven and haze and inorganic or atmospheric chemistry driven haze problem in the National Capital Region. So you see what basically there are 2 sites we have used here data from. The one is IITM Delhi, which are near Rajendra Nagar. Another is IIT Delhi. And we have tried to look that when is the agriculture burning, AGB, is contributing to the very high amount of PM 2.5, which led to significant amount of haze in the city of Delhi. So I'll just stop it here, and I'm I'll be happy to take some questions if there are some. Thank you.
Thank you, sir. Now the forum is open for questions. Attendees can ask question or type the questions in the.
Thank you, Professor Tripathi. This is Devabroto from Physics Department, SRM IST. So I have just one basic questions. So all the data where you are using this PMS 3003 sensors. So I have also measured different type of PM 2.5 by using this type of different sensor like PMS 3003, T006, 5003, SD011, HPMA 115. So how you can say all these sensors are reliable with compared to TSI dust track like 8530 or 8533? Like if we compare that, like if we are taking the data from TSI 8530 or and if we are taking the data from this PMS sensor, so how it's reliable, like the low cost sensor and the higher cost sensor?
Well, generally for assessing the sensor's accuracy, we there's only in one case we have used TSI, research-based instruments, but otherwise the best way to approach this is to use the BAM or EBAM, which is a equivalent grade monitor used by all the regulators. Okay, and the idea is that you try to the basic idea is to try to co-locate. You place the sensor next to BAM, and there's no artifact, and you also measure temperature and relative humidity because these two parameters very strongly influence the performance of sensors. And do it for at least for a week or maybe for 10 days, so that you have hourly, let's say 240 or about 300 data set for different seasons, so that you capture. The idea here is that you should capture different range of PM 2.5 concentration and also different composition of PM 2.5 and different temperature and RH. And then we try to actually look into the relationship, and then you try to then also go for advanced statistical tests, and then looking at that, then you finally arrive that what's the performance. So basically, then you can look into different matrices. You can look at RMSE, or you can look at MAPE, depending on what's the concentration. You can look R square, and you can start with very linear, simple models, and you can go to progressively, you can go for high version of and better and better machine learning models. That's the basic idea. But you can read more about that in some of our papers.
Because sir, why I am asking, because the TSI is most the dominating company throughout the world, and they are so much cost one instrument. So it is not possible to buy lots of TSI and install throughout the cities. So instead of that, if we are getting very good data from these low cost sensors, so yes, we can use, as you are telling. Yes, thank you, Professor. Thank you.
Thank you, sir. Thanks for the nice presentation. Now I request the next speaker, Professor Dr. Yogesh Tiwari. Dr. Yogesh K. Tiwari received his PhD degree from Max Planck Institute for Biogeochemistry, Jena, Germany in 2006. He is currently working as a scientist D in Indian Institute of Tropical Meteorology, Pune, India. He has a total of 32 publications, which includes peer-reviewed journals published in international and national research reports and published as conference proceedings. Now I request Dr. Tiwari to take over the guests.
Okay. Respected Professor S.N. Tripathi, Dr. Paramita Chakraborty, and all. Good morning, good evening to all of you. I hope you can see my slide now.
Yes, sir.
Yeah, okay. So as I was introduced, I am Yogesh K. Tiwari from Indian Institute of Tropical Meteorology. And Professor Tripathi has talked about the air pollution, air quality monitoring, and then modeling development in India. So I will take you to the greenhouse gases, which is basically a very important tool which really affecting the climate in India. So the topic which I have chosen is unraveling the mechanisms of atmospheric greenhouse gases variability in India. So I would like to acknowledge, first of all, my all PhD students and postdocs who really contributed to this research. So basically, what is greenhouse gas and its effect on climate? So many people know that what is greenhouse. You can see the ground picture that it's kind of a glass house which is used for the agriculture. So the gases which we emit through anthropogenic activities in India, CO2, CH4, N2O, CFCs, many other gases are there, HFCs. They actually work as heat trapping, and then they act, they warm the atmosphere, and then they call it a greenhouse gases. So now, so why we should give actually much attention to the greenhouse gases? So you can see here, so there are three major reasons. It's radiative forcing, global warming potential, and lifetime of GHGs. So its radiative forcing of carbon dioxide is close to 2 watts per meter square, and then methane and halogens and many other GHGs are there. And so net human radiative forcing is more than 2, and its global warming potential also is very high. And then lifetime of CO2 is close to 100-year time scale, methane is close to 10 to 12 years, nitrous oxide is close to 100 years. So once they emit in the atmosphere, they basically stay in the atmosphere for longer, and then they affect the atmosphere. So what are the major sources basically? So major sources of carbon dioxide are fossil fuel combustion, deforestation, cement production, and methane is fossil fuel production, agriculture, and landfills. Nitrous oxide is basically fertilizer application, fossil fuel and biomass combustion, and industrial processes. So all they are basically responsible for the health and societal issues on the long term and then short term. So what is the world fossil fuel CO2 emission during 1970 to 2018? So you can see it is basically the country wise. So China, and then United States and European Union, and then India and Russia and Japan, and then there are other countries, and then international shipping and aviations. So in that case, well, China is much ahead in emitting the fossil fuel emissions, and then India comes somewhere, see, after Russia and then after Japan, but still it shows that it is increasing. So this is this data is basically from EDGAR database. So and then the major fossil fuel emission basically comes from the coal power plants. So you can see the power generation using the coal in the world. China is the top, and then after that US come, and then India, and then Russia and Japan. So these everything goes to the atmosphere as a greenhouse gas. And then if you see India, the power generation sources, this is basically the government data. This is from CO2 baseline database from the Indian power sector, from Ministry of Power. If you see 31st March 2005, the coal was used almost 55% to generate the power. But by 31st March 2019, the coal amount is used 69.7%. So it really reflects that if you use more coal, it means there will be a more fossil fuel and then more greenhouse gases emission in the atmosphere, which basically convert to the climate, affecting the climate and to the health of the society. And here the important point, if you see, the hydro was almost 26.9 and it is slowly reduced to 16.4. It means using a coal is very easy. But the effect is really very serious in the atmosphere. So what is the Indian GHG budget? What is the global perception? How the India looks to the global? This is basically a paper published in 2013. And this covers three gases, CO2, methane, and nitrous oxide. So you can see, I will not go in detail about every tracers, but if you see in detail, so India is net source of GHG. It's almost 334 teragram carbon per meter per year. And then it has a CO2 sink of means it's 147 teragram carbon per year. So we have a source which is increasing. So if we see over South Asia, other than concentrate over the area where basically India is a major chunk. So you can see this is Bhutan, Bangladesh, India, Nepal, Pakistan, and Sri Lanka. And then this is 1990 to 2009. So the black line is a total of all emissions. And then the blue line is India. So in South Asia, basically India is a leader in fossil fuel CO2 emissions. So you have seen that with the growing economy, we need a more energy. And then for that, we need more resources. And then more fossil fuel are emitted. So GHG observations are really required, as well as modeling are important tool to understand basically GHG variability. So it comes as a sources and sink also in India. So what are the GHG observation and modeling activities in India, what we are running right now? So we have a GHG monitoring at surface sites. We have a carbon flux measurement network in India, and we are doing airborne GHG monitoring. And then we have done GHG monitoring at the ship deck. And then we have a tall tower GHG monitoring in central India. And then we have established the GHG forward and inverse modeling at our institute here at the IIT. So I'm giving just example of one site. This is basically a site, it's known as a Srinagar GHG Observatory. The old name of this site is Kondana. I mean, actually, basically it's a fort. And we have a tie-up with BSNL. And then we have our own tower within the BSNL campus. So this is IITM container. This we have started sometime in 2009. And you can see during the wet season, this is not basically a forest. This is kind of a grassland. During a wet season, it's completely green. But same time, if you see during the dry season, it's completely dry. So there are no grasses or something. So there are a very good seasonality at this site. So what are the techniques? So basically, we take a sample from the tower in some specialized glass containers, and then a sampling unit. And then we bring to the central laboratory at the IITM, and then we have analysis laboratory using gas chromatograph. And we use NOAA standards for calibration, because this is very crucial, the calibration issue. And then again, the containers go to some conditioning unit before sending to the field, just to clean it inside the flask, so that the air inside, which is basically clean. So all this protocol is basically followed through the WMO and through the NOAA, which is basically leader in greenhouse gases monitoring in India. So this shows the Srinagar, what is transport processes, basically from where the potential emissions sources, the directions. So this is basically potential emission sensitivity at Srinagar. So you can see during the winter time, January, February. So the sources are basically concentrated over the western Indian part. And as soon as if you enter to the pre-monsoon time, the wind moves towards the Arabian Sea, and then monsoon time, it is completely Arabian Sea, and again post-monsoon time, we have from the continental. So basically we have a seasonal reversal of wind pattern. So wind reverses, and then we have information from both the sides. So this is basically long-term observation. You can see we started almost end of 2009, and this is 2010 to 2019 record, and still we have some record of 2020 also. This is CO2, carbon dioxide, and this is methane in the atmosphere from the Senegal side. So there are a lot of other variabilities. For example, atmospheric methane has sub-seasonal variability over India. So this is power spectrum of detrended and deseasonalized observed surface atmospheric CO2, atmospheric methane mixing ratio at Senegal, and then one more site at Cape Rama. This is in Goa. So, and then this is basically compared and then used with the models, 2 or 3 models are there. So atmospheric methane shows some sub-seasonal variability also. So, and then there are some active and break composition evolution. So we have used the model and then we have seen how the atmospheric methane varies with the active and break phenomena during the monsoon time, and then what is its impact to the atmosphere. And then we have set up a NICE, a model in collaboration with the NICE Japan. So we have developed it over the Indian domain for the forward and inverse modeling. So this is just basic result of model validation using the observation in Senegal for the CO2 and methane. So you can see upper plot, basically the CO2 seasonality from 2009 to we have done till 2014. So both model and observation has a quite good agreement. And then if you see for the, sorry, this is the methane and this is atmospheric carbon dioxide. So these differences arise due to the fluxes which we use in the model. This is basically the inversions, inverse model we have developed, and then we are trying to estimate the CO2 fluxes over different locations, including India and other part of the globe. So this we have tried to see how, what is the use of the site Senegal. So when we use Senegal and when we don't use Senegal, how basically they impact. So you can see during the winter time, January and then February and then March and then April and again November, December, basically the uncertainty reduction, this is basically uncertainty reduction is large when we use the site. So it shows that if we have an observation, then the credibility of the data is more. So recently we have published one result using this model in JGR atmospheres, and then we have done some sensitivity experiment, and then for the CO2 enhancement due to the biospheric and fossil fuel fluxes from India into the global atmospheric background. So basically how much India contributes to the globe, the atmospheric CO2. So, and then we have found that the Indian carbon fluxes significantly contribute to the CO2 concentration as large as 2 ppm over India and neighboring regions throughout the year at surface level. So this is basically, this left side picture is Indian biospheric flux. And then this is enhancement due to biospheric flux, and this is enhancement due to the fossil fuel flux. So the overall India contributes to the globe every season 2 ppm. And then these informations, basically the greenhouse gases information are really required to the policy makers also. So we have done methane inverse modeling, and then we have estimated methane fluxes using top-down approach using the inverse modeling and observations. And you can see this is basically country scale analysis of methane emissions with a high resolution inverse model using satellite and surface observations. And then here we have compared our result with biennial update reports with what India reports to UNFCCC. So BUR 1, 2, and then this is Edgar, and basically this is top down, the red one. Sorry, the green one is our estimations, and then yellow one is basically the running mean of our top down, and then this one is basically BUR2 from the India. And then we have basically compared the model with our airplane campaign vertical profiles also. So these are basically this information actually taken by the Ministry of Environment and Forest. And then in 2017, we had one paper in Nature Communication where we showed that atmospheric observations show accurate reporting and little growth in India with methane emission. And this information was basically taken by the WaARISH for validation of the bottom-up inventories. And then it was basically available in UNFCCC website. So this information basically are very useful, and then goes to the helps to the countries reports and these things. And at the same time, we have a CO2 flux measurement, a source sink measurement at different ecosystem in India. So we have two techniques. One is inverse modeling, we can estimate, and another is there we can monitor it directly at the point sources, so at different ecosystems. So IITM is running MetFlux project. This is part of MetFlux project. So we have different sites, and then we have a tower which is basically used for GHG fluxes. And the one example here, we have a tower in Kaziranga National Park. This is a 50-meter tower, and it is installed in 2013, which is measuring basically all kind of carbon fluxes like NE, net ecosystem exchange, and various radiative parameters, and then various other parameters. And then we have compared with the different locations. For example, CO2 flux at what are the different locations, diurnal variation of the CO2 fluxes. For example, this is Mahbub Nagar, Betul, and then various other locations. And we have found that during basically the early morning, the morning time around 10, 11 o'clock, it shows that CO2 flux is negative, means it acts as a more sink. And basically, and then we have compared it. You can see it is different locations, and then Betul, and then this is basically over the Ganga basin. This is over the Hyderabad, the Kaziranga National Park, and this is over the Chennai. So we have compared how the carbon sink basically varies at different locations in India. This is direct observations. And then we have done some observations using the airplanes. We have used the airplane, we have used the instrument, which is high resolution online measurement, and then it monitors atmospheric methane, atmospheric CO2, carbon monoxide, and then water vapor at very high resolution every 1 second. So in 2014, 15, 18, and 19, basically 14, our focus was Ganga Basin. And 15, 18, and 19, basically it was over Maharashtra, over Kolhapur, and then over Mahabaleshwar, Solapur, and then some flights we went inside the Arabian Sea also. So we have taken horizontal and vertical profile both. So I was personally involved in this project, and then we have used all NOAA calibration cylinders for calibrating the instrument so that we can see the data reliability and the instrument stability. And this is just one example of flight. So basically this is methane, July 2015 at Kolhapur site. So a very nice pattern you can see at the surface. It is high. As soon as we go up, then it is it really decreases, and then basically it peaks at 1860, and then again it decreases. So if we see the carbon monoxide, it shows a similar kind of structure. So these structures, basically, if we see in the model, we may not understand, basically model may be wrong or something, but if we find such structures in the atmosphere. This is over Kolhapur site. And if we see over Varanasi area in September 2014, it was almost end of monsoon. So it was high at the surface, and then slowly it is basically decreases with the height, and then carbon monoxide also is same. And this one is basically looking the slope at every 0 to 2 to 5, and then 5 to 8 kilometers. This is very interesting plot. So we have compared with the 3 different models. This is CAMCAM model, and this is LMDZ model, and this is ACTM model. So these 2 are basically chemistry driven models. So if you see over Kolhapur, Solapur 2015, the pattern of all the models looks same. So model basically captures the pattern, overall pattern. If you see over Ganga Basin, then model capture over the Ganga Basin also. And then we have one more site in Mahabaleshwar, then same thing. So if we see only the model, so we cannot understand the vertical transport unless we have the observations. So this is just very preliminary result. So it shows that, so such observation has the potential just to understand the model's vertical transport. And then those models are involved in basically understanding the carbon estimations, estimating the carbon emissions over the globe as well as over the India. So if we validate those models and then use this data, maybe this airplane data, then that will give a very valuable information. So basically, you can see over, this is just one hypothesis we have given why we get the high over here, over say 4.5 kilometer low at the surface and high here and again goes. So just we have assumed that there is southwesterly monsoon winds, and due to convection, when the air mass goes up, and then at 4 to 5 kilometer, it comes in a easterly flow, and then it basically circulates over here. So we see the surface emission, which is lofted due to convection, and then basically this is captured by the observations. So there were some monitoring over the ship deck we have done over the Bay of Bengal. So at different locations, this was basically a cruise ship track started from Chennai, and then it moved at different locations and then came back. So, and we have found a very distinct feature in this. There was some king at one location, basically, which was near some coast or something like that. And then same kink model also were saying, and then basically we have found the satellite also. So this was very useful to understand the land ocean contrast over the Bay of Bengal. So this is fossil fuel and biotracers over the Bengal, which very used to understand the land ocean contrast. So if we have say emissions over the land, so with the transport, how it moves toward the ocean during particular time when the air mass moves, and then how much it moves goes inside. So we have basically GHG monitoring observatory. It's a tall tower observatory in central India. So we have a 72-meter tower, and then we are monitoring GHG profiling at various levels, as well as we have all kind of soil monitoring, for example, soil flux, and then soil temperature, heat flux plate we have, and then we have even eddy covariance instruments at 2 levels. So it's kind of a test bed. We have all the monitoring. So you can see it's all entire instruments. So it has even isotopes, delta 13C of CO2 and methane, and it is an entire suite of GHG, and then we have eddy covariance, and then soil CO2 flux system, and we have photosynthetic activity. So everything is there. This is the tower schematic. So we are monitoring at various levels. So this is potential emission sensitivity at Bhopal. This is very good site because you can see almost in every season except monsoon season, it really samples the Indian continental mass, which basically is really an important tool to understand the emission of Indian continental sources. So this data will be very useful. Now I wanted to bring your attention at Professor Tripathi showed that during the basically COVID time, how the air pollution decreased, and then what was this impact to the atmosphere. But in terms of greenhouse gases, basically what happened. So CO2 emissions reduction due to COVID-19 induced lockdown in India. So you can see this is basically during the 2020 lockdown when March it happened. So basically emissions of CO2 emissions decreased over India. This was holy time, and then after that it decreased, and then again got pick up maybe July, September or sometime. And this is the global, so almost same time it decreased. So there are the reduction of CO2 emissions over India, and also other countries. For example, China, it was early because their lockdown was early, and then US, and then Italy and Spain, also various locations. And if we see basically CO2 emission variation in percentage. So during basically the same time, during the March-April time, it has the basically 4 to 4 to 5% even it was the reduction. And how much it converts, so that time. So this is power generation using coal in India. So basically entire country was in lockdown, and then power demand was very low. So that time you can see the basically this power generation using coal was really reduced. So you can see it was almost 1900 megawatt. Otherwise, generally it is 2900 megawatt. So during March and April time, it really reduced, and then again picked up during the July, August. So there was entire fossil fuel emission reduction was there. So this is basically from Power System Corporation Limited, Government of India data. So now there, however, there was no reduction in observed atmospheric CO2 concentrations. Basically, when there is a CO2 emitted in the atmosphere, that is emission. So that reduction was there, but concentration, which is basically well mixed, three-dimensional quantity concentration, that was not reduced. If you see the global data, so global data, there was no effect. Even see 2020 March, April, nothing. So it was almost going on same pace. This is monologue data. And over India also we have found, we have just compared the seasonality 18, 19 and 20. There are not any change in the reduction or either February, March, April or anything. So why basically this has happened? So this is just one schematic I wanted to show you. So basically our atmosphere is like a big chunk of bowl, and then this is atmospheric CO2. You just imagine a concentration here. And this tap is basically surface CO2 emission. So during the lockdown, we just reduced the flow of this tap. But whatever we have already emitted, this is already available in the atmosphere. So COVID-19 lockdown did not show any reduction in atmospheric CO2 concentration, because whatever already we have in the atmosphere, that will remain as it is. If you close this tap, then also it will be there. But if you close this tap for some time, then it will have some reduction. But partially closing this tap will not affect this one. So the atmospheric CO2 concentration, which is basically used to the model to understand the CO2 emissions estimations, they did not affect it. So this is all about this atmospheric greenhouse gases, and I am really happy to take the questions. Thank you.
Thank you very much, Dr. Tiwari. It was like excellent presentation. Now the forum is open for questions. Yeah, you can either type it or you can ask. Just raise your hand and unmute and ask. Yeah, I don't see anybody asking yet.
Okay.
Just one curiosity from my side.
Yeah.
Because as you rightly said, like in terms of organic contaminants also, we are not seeing a decreasing trend at all.
Exactly.
So is it like we are suspecting that this open burning of mostly biomass, or even like open burning of solid waste,
yeah,
that is not stopped even during lockdown? So could that be one reason for also that the levels that we are seeing has not drastically reduced?
Yeah, exactly. I agree with you, because during the lockdown, all government machineries were affected, and then also during the cities, we had low emissions. But as rightly you said that some burning issues and then some other local emission issues still were there. So that's why in the background, so background was still high. So overall it was low, but background was still high, and then it was not showing in the observation exactly whatever it did in atmospheric CO2 concentration, methane concentrations. So I agree with you. So if we have to really take the results, so we have to completely close it, but that is not possible because of various reasons and then economies and these things. Yeah.
Absolutely, I completely agree. And this was really wonderful. And the way, especially the last slide you showed, was very, very, I think, especially for young students, very informative.
Yeah.
So I'm still looking forward. There's no question from anybody here. So if not, then we would like to thank Dr. Tiwari for his wonderful talk. And thank you for getting associated.
Thank you.
To see you more here.
Yeah, thank you.
Thank you very much.
Yeah.
Thank you. So we have a special session now, which is for early career researchers, and we have very young and bright and dynamic early career researchers here who would be delivering their talks. And I now request another upcoming early career researcher from my group, Ms. Moitri Mukhopadhyay, to take it up and introduce each of the speakers for this session. Over to you.
Thank you, ma'am. Good morning, everyone. So the first young researcher we have among us is Dr. Refilvi Mofokeng. Dr. Refilvi Precious Mofokeng has a PhD in marine ecotoxicology from the University of KwaZulu-Natal. Passionate about mobilizing communities to protect the planet, she has received the Wonder Woman Award in 2015. Her current area of research interest is the impact of climate change on marine ecosystems and providing sustainable solutions for all stakeholders involved. I would now request Dr. Refilvi to deliver her talk, please.
Thank you. Can I share my screen?
Yes, please. Yeah.
Okay, thank you. I think first of all, I'd like to thank my mentor, Professor Paro, for having me and having me participate in this program. I've already heard very, very interesting talks, and some of which were new to me and new technologies. So I really much appreciate that. So part of this research was funded by the National Research Fund in South Africa, the NRF, and as it has been stated, I am from the University of KwaZulu-Natal. I'm currently doing my postdoc in the health sciences. This work that I'm presenting was part of my PhD that was conducted between 2018 and 2019. So it's really pre-COVID times. The title of my paper is the association between microplastics and metal concentration in Durban Harbour sediments in South Africa. Durban Harbour is an estuary, and as there are different definitions of estuaries out there because of the different varieties of different types of estuaries, we have decided to adopt the one by Day 1980, which is a more broadly accepted sort of definition. Essentially, estuaries are immediate receptors of contaminants from runoffs and rivers, and they also form a link between fresh water and salt water. The estuaries are quite important because they serve as nurseries for marine animals and are often aesthetically appeasing, meaning that they attract a lot of tourists. And in a country like South Africa, they get to be really important both biologically and economically. So they have a very significant role to play. So Durban Harbour is situated in Durban. Durban is along the Indian coast of the Indian Ocean coast of KwaZulu-Natal. It is the second largest city in South Africa with a population of about 3.7 million, but this does grow, just quite exceptionally during the summer months, because as I said, Durban is a highly touristic environment or area. It is a relatively wet catchment with exceeding like 1,000 millimeter precipitation annually. Durban Harbour in itself spans for more than 673 hectares, and it has 3 freshwater conduits, namely Umbilo, Amhlatuzana, and Amanzimnyama. However, because the harbour is a permanently open estuary, it is mostly saline throughout the year. The purpose of this paper was to determine the association of microplastics, of metal accumulation with microplastics, as well as to understand the survival and tissue accumulation of the metals in the gamma-rich estuarine amphipod, Grandidierella lignorum, throughout Durban Harbour sediments. And our objectives included to understand spatial variation and association of metal and microplastics accumulation in different parts of the harbour, as well as to determine the survival and metal tissue concentration in Grandidierella lignorum throughout different exposure sediments in the harbour. And I just want to really explain why we chose the amphipod, because as you know, or you might know, some of you, that amphipods are literally the engineers or part of the engineers of the ecosystem. So chances of accumulation and bioaccumulation of metals in the amphipods throughout the food chain are quite vast. So that is the reason we chose amphipods for this experimentation. So we hypothesized that the presence of microplastics will increase metal concentration in Durban Harbour sediments, and that spatial and temporal variation of metal concentration in the harbour will be evident. So this is the study area that we have. Durban Harbour is separated into 3 major sandbanks. However, for the purposes of the study, we further divided the sandbanks into 5 different sandbanks, and for purposes of land use. For instance, the Yacht Bank, as you see, will have boats, and therefore it's susceptible to biofouling and oil spills. And when you look at the central and western banks, there's a lot of loading and offloading activities happening from big ships and shipping companies, given that Durban Harbour is one of the busiest harbours in the sub-Saharan Africa. So it's a very active harbour. So that site was quite important to us. And the Little Lagoon was also quite important because it was relatively isolated, and there was no sort of evident point source contamination in that area. All acids and chemical used in the study were purchased from Sigma or the Analytical Chemistry Lab in South Africa, unless stated otherwise. And the standard verification was done through the spec certification prep. All the containers were pre-washed using deionized water and doubled deionized soap and double distilled water. Experimentation or collecting of sample was conducted subtidally using the Cora and sieves with buckets, as you can see with the first picture. And then the samples were then transported to temperature chambers at the University of KwaZulu-Natal and cultured for 6 months in culture trays. And then they were exposed to various well, a 6x5 grid for various experimentation procedures. Sediment was dried, sediment and amphipods were dried using the lab oven at 60 degrees Celsius. And for microplastics analysis, the SMI unit, which is the sediment microplastic isolation unit, was used to separate microplastics and sediment. And the Nile red staining technique was used to stain microplastics for viewing under the electron or fluorescence microscope. And then for chemical analysis or metal analysis, an ICP OES was used for both metals, for both sediment and amphipods. So figure 2 there would show you the images of what we see under the fluorescent microscope. And as you can see quite evidently, you know, the microplastics are quite easily visible with this procedure. So it was relatively easy to identify. However, one challenge that we did have with this method, because it's a, you know, fairly rudimentary method, was that, you know, it does tend to fluoresce, the Nile red does tend to fluoresce skeletal tissue as well. So yeah, we had to really pay attention as to not overestimate our data. And for that, we just opted to have a high limit and a low limit of detection. So microplastics were detected in all sample sites with varied distribution and concentration ranging from about 0.2 to 2.7 particles per square meter. As you can see, there's, you know, up to an order of magnitude difference between microplastics concentration at different sites. And this is one of the very, you know, concerns of scaling or modeling microplastics, because it's really difficult to understand the trajectory for various reasons. One, microplastics are both primary and secondary microplastics are fragmented differently, and also they can have, you know, biofouling, which you know, contributes to the density of the microplastics, and then also, you know, informs its transportation and buoyancy. Also, we did see that the ANOVA did report that there's no significant difference between you know, different sites that we collected at, but then, you know, when at first glance you think there's a vast difference, but then again, it's also evident in the standard deviation with the larger sort of sample sites. So it really is difficult to predict the trajectory of microplastics. Survival of amphipods was generally high at all sample sites, except for, you know, the Marina Bank, which was a little bit lower than the rest. And we'll just explain that quite shortly. But generally, you know, the exposure was over a period of 10 days. So it was a relatively acute exposure. Yeah, so it does not necessarily mean that, you know, Devon Harbour is safe. It just means that, you know, we didn't look for steady chronic effects. It's just, you know, just really tells us over a short period of time what really does happen. So we didn't see any impact on the survival of microplastics, and further correlation between microplastic survival and or amphipod survival and microplastic concentration also didn't show, like, you know, very high concentrations. On R2 value of 0.57, it's not really strong. You know, again, you know, meaning that there was really no correlation between survival and microplastics presence. So figure 4 will show us that, you know, sediment concentration of metals in various areas was quite different for different metals, was varied for different metals. So for metals such as aluminium, chromium, iron and zinc, you did see that there was a little bit of a, sort of a uniform presence, even though it's not the same concentrations, but there was somewhat of a uniform presence throughout the sites. However, other metals such as the copper, magnesium and lead did show, just really, points of a spill or points of, an anomaly in different sites, and particularly the Western Bank. As you can see with the Western Bank, we did say that it is an offloading of an unloading site, and that can be a result, there's a high susceptibility of spillage that can happen in that area. So because of that,
I'm sorry to interrupt. Your allocated time is over, so I would just request you to pass
Oh, is
on
it-
the presentation. Yeah.
or is it done now?
Yes, ma'am.
Okay.
You can continue it. There's no problem, but you kindly try to wind up.
Oh,
faster.
okay. All right. Okay. Thank you. All right. So again, what we wanted to show is the tissue accumulation also was evident in the amphipods. So that was your figure 5, that what this shows us that amphipods are really net accumulators of metals. Okay, this graph or table shows the sort of a temporal scale where there is the difference metal concentrations between different seasons. As you can see here, some metals were apparent in one season and not there in another season, and this was further emphasized by the temporal variation ANOVA, where there was significant differences in different parts of in different sites. So in conclusion, there was uneven distribution of microplastics, and there was also high amphipod survival following exposure of G. lignorum. As a result, we do fail to accept the first hypothesis that the metal accumulation is associated with microplastics abundance. However, there was definitely a temporal and spatial variation of metals and microplastics in Durban Harbour. Thank you.
Thank you, ma'am. The session is open for questions now. I think we can take 1 or 2 quick questions. Thank you, ma'am. Thank you. Thank you, Dr. Rapolo. I think we'll move on to the next speaker, which we have, who is Dr. Sanjeev Dwivedi. Dr. Sanjeev Dwivedi currently works at the School of Earth, Ocean and Climate Sciences, Indian Institute of Technology, Bhubaneswar. Dr. Dwivedi does research in monsoon low-level inversion, boundary layer, dust, monsoon, climatology, and meteorology. His most recent publication is Characteristics of Monsoon Inversions over the Arabian Sea observed by satellite sounder and reanalysis datasets. I would now request Dr. Dwivedi to kindly deliver his talk.
Warm greetings to all. Shall I share my screen? Suppose I think other person didn't unshare till now.
Dr. Rapolo, could you please unshare?
Dr. Rapolo, yeah, please unshare your screen. Yeah.
Ma'am, Dr. Rapolo, could you please stop sharing your screen?
Hello. Yeah. Thank you. Now I'm able to share. Yeah. So, is it visible?
Not yet, sir. Have you started sharing your screen?
Yeah, I did. Shall I share again?
Yes, sir. Please do it.
Yeah, I'm sharing again. Share screen. Share mode. Now is it visible?
Yes, sir. It is visible.
Okay, so yes. So warm greetings to all. So my topic is monsoon inversion, formation and maintenance mechanism over Arabian Sea, and its impact on pollutants concentration over coastal stations of India and rainfall over country. So my talk objectives are to study the formation and maintenance mechanism of MI, to observe the influence of MI over the rainfall, and finally, distribution of pollutant, how MI is impacting. Here's the data used in my study. So first of all, what is monsoon inversion? So normally we know when we are going up in the atmosphere, in the troposphere, temperature is decreasing. So in general, temperature lab is nearly 6.5 Kelvin per kilometer. However, on some occasions, due to the quicker surface cooling during sunset hours, winter seasons, etc., inversion gets formed. Over the Western Arabian Sea, the inversion gets formed during the months of monsoon, which is much stronger. The inversion is of strength -6 Kelvin per kilometer and long lasting. So why I'm studying this inversion? So what is the rationale for my study? So monsoon inversion acts as a lid and prevent moisture aerosol from going to the higher levels. Second reason, if we observe over the region of inversion, we have very less cloud or low cloud, so it's impacting the rainfall. So this is the central one is showing the strength of MI, monsoon inversion, which is nothing but delta T is temperature at 950 hectopascal minus temperature at 850 hectopascal. So when this is approximate temperature difference of 1 kilometer. So if its value is coming negative, means that we have inversion. And we have divided the Arabian Sea into 3 boxes: Western Arabian Sea, Central Arabian Sea, and Eastern Arabian Sea. So over the Western Arabian Sea, we have inversion, and it is below 1 kilometer. And when we are moving towards the Eastern Arabian Sea, it's going up to 1.5 kilometer above that. So frequency of occurrence is also shown in this graph. So next, how this inversion is getting formed. We know during the monsoon season, the Shamal jet or the hot desert wind is coming from Arabia side at a height of 700 hectopascal, almost 3 kilometer height. At the same time during monsoon, the monsoon cold current is coming from the southwesterly side, and the warm current is overlaying over the cold current, which is creating a inversion like feature. At the same time, Ekman transport from the ocean, it's a cooled SST, cold water is upcoming, so it is making a inversion layer. And the same time, the other reason is convection, the subsidence associated with the convection over the mainland. So these are the 3 basics reasons which we have studied in our work. So these are the reason we have find that during the pre-monsoon season, subsidence is the main cause of the inversion over the Arabian Sea, especially it is over the Eastern Arabian Sea. During the monsoon season, further we divide into active and break spells. So during active spell time, subsidence component is small. We can see the thickness level, convection is large, and the southwest monsoon winds are stronger. So due to the advection of the wind, the inversion is getting formed over the Western Arabian Sea and Arabian Sea. During the break spell time, subsidence is getting much important, a dominant component during the break spell time as compared to the monsoon current. So this is my finding for the mechanism and formation. The advection and subsidence both are acting at the same time. Then I found out that for the delta T over this region, that MI index, and the rainfall over central India region, it is giving hand-to-hand correlation. So then I started to see the correlation spatially. So we see June, July, August, September, the second day lag when I am seeing inversion delta T over Western Arabian Sea, and after 2 days rainfall over the country. we are seeing the signature here that delta T is giving a negative correlation over the central India region, June, July. Overall JJS, it is giving a negative correlation. Means when the inversion over Western regions is getting formed, it is acting as a lid. It's not allowing the cloud to grow up. So the rainfall scanticity is seen over the central India region. And once this inversion is coming over Eastern Arabian Sea region, it is showing some reason positive correlation over the Western Ghat area and other thing. So inversion, once this inversion is getting disturbed by some mechanism, then there is a huge amount of rainfall is occurring over the coastal India region. Then we have seen the relative influence. The rainfall distribution over the Arabian Sea follows the same pattern of the lapse rate with a relatively less rainfall. We can see here the rainfall amount, wherever the inversion is coming, the rainfall amount is decreasing. And it's oscillating same as the inversion is oscillating at the top panel. And the wind shear is shown, which is the reason for one of the reason for the inversion. Then coming up to the inversion and the pollution relation, we know the fog phenomena, smoke over our Delhi and other regions also. So when we have seen the inversion things, and we have found a temperature inversion of high value. And we know from the theoretical background, the temperature inversion layer, it's trapping the pollutant in the lower level. So this pollutant is not really going to the free atmosphere and making health related problem for our country person or any region person. Now the effect of monsoon from satellite, we have seen that delta T over Arabian Sea region in the April and the monsoon season, July-August season. So when the delta T inversion is increasing during the monsoon season, we are seeing that CO2 mixing ratio is enhanced by 2 units over the central India region. And during the April, its value is around 384 to 385. But due to the inversion region and inversion things, it's one of the factor out of other factor, which is giving 2 millimeter enhancement. So its value is 386 to 387 ppm. Then we have did the cluster analysis, and we had found that the wind coming from desert area, almost 52% over Salalah station, 33% over Muscat station. And this is a mixture of these things, which is stratifying the inversion layer over the Arabian Sea region. This I did one ozone back trajectory analysis. So here 5 days back, the ozone's emission mass flux is shown over a Western Arabian Sea point, from where all the pollutant concentration is coming, and backward transaction is back trajectories are showing that the Arabia region and even from ocean also the ozone is coming. Then this is a preliminary result I'm showing from the high split model. What we have observed here, if we see the vertical particle distribution, this is 5-day forward back trajectory from that point. The particle, because these are the days when we have inversion over the Arabian Sea, and we can see the height level, it's around 1000, 2000, within 2000. When it is starting the emission, it's not allowing to go upside. So what is happening? The pollutants are trapping inside this. Once it is going inside the central India region, then it is going to the higher levels. And here the same thing, the pollutant concentration in picogram per meter cube I have shown. So these are the interesting results, which is showing the relation between the pollutant concentration and particle concentration and the monsoon inversion. So conclusion of my study, initial formation of monsoon inversion during the June due to subsidence, and later maintenance due to both advection and subsidence. It is the initial wind shear anomaly and the temperature advection that support the formation and the prolonged maintenance of MI over the Western Arabian Sea. The spatial rainfall pattern exhibits a steady increase with the decreasing lapse rate over the Central Arabian Sea and a maximum rainfall over Eastern Arabian Sea. And the final conclusion, high split and the flex part simulation shows the spatial as well as vertical distribution of pollutants. Here's my acknowledgements. Thanks for my institute that I met department to provide me permission. And I'm thankful to Dr. Paramita Chakraborty ma'am for giving me opportunity, and WaARISH organizers. And these are my co-authors in this work. Thank you very much. And I'm open for question answer discussion.
Thank you, Dr. Dwivedi. The session is open for question. You can just unmute yourself and ask the question or leave it in the chat. All right, Dr. Dwivedi, I don't think we have questions right now. If we have it later, somebody can put it in the chat and we'll come across with it.
Okay, okay. Thank you,
The
thank
next
you.
speaker whom we have is Dr. Hassan Al-Shamari. Dr. Hassan Al-Shamari is an environmental scientist working with organic contaminants. He's serving as the director of Stockholm Convention Regional Center for Capacity Building and the Transfer of Technology for West Asia in Kuwait, and has vast experience in the environmental analysis and assessment. He has been involved in the various analytical methodologies developments, especially the establishment of regional center for persistent organic pollutants. He is the key person for the development of NIP for Kuwait on persistent organic pollutants. Dr. Al-Shamari, I would kindly request you to deliver your talk right now.
Hello.
Yeah.
Yeah.
Hello,
Can you hear me?
yes, sir, we can.
Okay. Now I will share my screen. Yeah. Is it visible now?
Not yet, sir. Could you share it one more time, sir?
Hello.
Hello, sir. Yeah,
Is it visible?
yeah, it is visible now.
Okay. Thank you. Okay, good morning to all. Today, I will give a small brief introduction on regarding the flame retardants and its potential health risk assessment based on the samples we have collected from the Sulabia, which is located in the Kuwait. So generally, I am giving a brief introduction to the PBDs, that is polybrominated diphenyl ethers, which are most commonly used category of flame retardants and which have been used in the wide varieties of applications like textiles, electrical devices, and other materials. And there are various PBDs which have restricted by Stockholm Convention, but still there are some industrial PBDs are available still in the market, like pentafoam, octafoam, and decafoam. These are the major three commercial PBDs present in the market now, and you can see the structure over here. And the main activities of PBDs, like why it is most important to study and why we are going to introduce these PBDs. Like PBDs considered and classified as a persistent organic pollutants due to the bioaccumulation, and it can it can travel from a long range distance. Like even you can see the trace availability of these PBDs in the poles like Arctic and Antarctic, where they are not used it before. And there are various human health disorders also, like it has classified as a carcinogens, and it has classified as a neurodevelopmental disease, etc. And how it will be transmit into the humans. So there are various route when it is reaches to the human, like we can like intake by oral ingestion, like including dietary intake and dust ingestion, or we can say that air inhalation, like inhalation of PBDs at home or wherever we are working, like with the job of electronics or industry, whatever it may be. and sometimes through the dermal contact, through the dust, or some people they are playing through the soil, because there are some traces of PBDs we can see in the soil as well. And you can see a simple picture I have taken from the View et al. 2020. And you can see that the transfer of these PBDs into the human through the different different routes, and you can see this from here. And in this study, we are mainly concentrating like the assessment of distribution of these polybrominated diphenyl ethers in the agricultural and non-agricultural soil of the Sulabia, which is located in the Kuwait. And you can see from the study area map where it is located in the Kuwait. And here I am shown the different site where we have collected our samples. The top site is like Sulabia non-agricultural region, and the down part is like agricultural part. And this Sulabia agricultural sector, actually it is lies in the middle of the Kuwait, where the soil is much firmer with a deep sandy consistency, good drainage, appropriate ventilation, and of course no salt and hard pans or impermeable layers. And the size of this is there are around 5,000 hectares, and 5,000 hectares of successful farms in this area. So when I am directly moving to the result and discussion session, so here I shown the distribution session in the non-agricultural region, and you can see that the different congeners of polybrominated diphenyl ethers, how it is distributed from each in the non-agricultural region. I have taken the average concentration in tetra form, like except BDE47, the rest all the concentrations are like very low concentration. And you can see that this BDE47 has a concentration nearly like 7.5 nanogram per gram. And when we are going to the penta form, that is BDE 100, 119, 99, 85, and 126, these compound are also showing very less concentration. Like you can say that 3.8 to 3.9 nanogram per gram, and along the observed location from the non-agricultural soil samples. And when I move to the penta form, like BD 100 onwards, BD 100, 119, and 99, and 85, and 126, these are very less concentration. And it has from like 3.8 to 3.9 nanogram per gram. And the most importantly, the DECA form, that is like the PDE 209, which is the most predominant form, like you can say like 18.705 nanogram per gram. And this is the most predominant form of container of PBD is present in the non-agricultural region. When I move to the agricultural region, compared with the non-agricultural region, the concentration in the agricultural region of Sulabia is comparatively higher when we are comparing to the non-agricultural region. And same like as I described before, here also the tetra form like PD47, and the nonna form of like PD206, and the deca form PD207. These are the major contributor, like the concentration reaches to almost like 6.46 for BDE207 and 9.37 nanogram per gram of BDE209. Then now we will move to the health risk assessment of these compounds, like how it is going to affect our daily life. Means
Excuse me, sir, you are not audible right now. Hello, sir. Excuse me, sir, you're not audible right now. I think he has some internet issues.
Maybe we continue with the
Yes,
next
ma'am.
presentation.
Okay.
Maybe continue with the next presentation. I think there's some problem with his network issue.
Yep. Okay, ma'am. So the next speaker whom we have is Dr. Omkar Gaonkar. Dr. Gaonkar is currently working as a program coordinator in the Chemicals and Health team of Toxics Link Environmental Organization. He has a total of 45 publication, and his area of research interest includes persistent organic pollutants, fate and transportation of POPs, and environmental analysis. Dr. Omkar, you can please deliver the talk now. Unmute him.
Good morning to all. Am I audible? Am I audible?
Yes, yes.
So today I'll present on our work on nonylphenol. Basically, we have detected nonylphenol in different detergent powders and water samples. So today I'll just present a summary of that work. So let us first understand what is nonylphenol. So nonylphenol is a complex phenolic substance, and it is mainly manufactured through the alkaline process, and it is used as a raw material in the production of nonylphenol ethoxylates. And the most commonly used compound of nonylphenol is 4-nonylphenols, which is like commercially 90% available. So if you see the chemical structure of nonylphenol, it has 9 CH3. That's why it's known as like nonylphenol. And when nonylphenols are used for the manufacture of nonylphenol ethoxylate, it forms more complicated. So the United Nations Environmental Program has identified this chemical as a chemical of global concern. And in the forthcoming slides, we will see why it's known as a chemical of global concern. So first, let us understand where all these nonylphenol ethoxylates are used. So they are used in paints, toys and games, footwear, food wrap, then indoor pest spray, clothing. So you can see these compounds are ubiquitous in nature, and they can be used for a lot of consumer products and day-to-day products. So how these nonylphenols and nonylphenols ethoxylates are released into the nature? So they are mainly released by the industrial processes, like when you manufacture nonylphenol ethoxylates from nonylphenols, or in the paper manufacturing industries, or the printed circuit board manufacturing, metal extraction, paints, textiles, detergents. So you can see a vast array of processes release this type of compounds. So why this compound is of global concern is nonylphenols have found to, like, they have shown to have toxic effects on aquatic organisms as well as on human health. So it has led to the feminization of aquatic organisms, also decrease in male fertility, and many fish are almost like very few survive at the fetal stage. And in human health effects, they have shown to affect the neurological system, the brain development, the reproductive system, and also they have been linked to cancer. So because of the ubiquitous nature of nonylphenols, they have been found in different matrices. So this is just a review or a summary of studies in which nonylphenol has been found across the globe. So you can see the nonylphenols have been found in garments up to like 45,000 ppm, then PVC wrapping film, and different food contact materials, the materials which are used for packing foods. And also they have been found in aquatic organisms like fish and mussels, because they are bioaccumulative to some extent. And then they have also found in different types of clothes, and also in blood sample of about 43% of women. Going ahead, nonylphenol has been found in water also across the globe, and including some Indian studies in which they have detected nonylphenols in Kaveri, Vellar, and Tamraparni rivers in the south, and Ganga and the Varuna rivers in the north. So apart from that, many studies have been carried out in China, basically because of the vast extent of manufacturing sector in China, and Brazil and Japan. So what were the objectives of our study, which we carried out to understand the environmental presence of this chemical? So we analyzed the presence of nonylphenols in detergents sold in Indian market, and also we detected NP concentration in different surface water samples, which we collected from across the country. And based on this results, we tried to bring some recommendations which is necessary for phasing out the use of this chemical. So we collected some 12 detergent samples from a local market in Delhi, and these detergent samples were the most popular and easily available. So which means that many people are using this brands of detergents. Apart from that, we also collected 12 water samples from different rivers and lakes across India. And from every river, we collected samples from 2 different points, like upstream and downstream. And also we did a preliminary assessment, like where are the industrial activities are there, and what are the anthropogenic activities nearby the river. And based on that, we selected the sampling site. So here you can see that we collected the samples mostly from Rajasthan, then the Tapti river in Gujarat, and the Krishna river in Andhra, and Ganga in Uttar Pradesh, and Mahanadi in Odisha, and a few of the lake sample like Ambazari Lake in Nagpur. So we found this nonylphenols are present in all the detergent samples which we tested of different brands. And they were present, like minimum was 0.25 and maximum was around 12%, which is very high. And many of these detergent samples were found in the brands which are international brands, and they declare their products to be free of nonylphenols in other countries. And in river samples, we found nonylphenols from the range of 9.2 to 41.2. Including the Ganga river, but the highest concentration was found in river Pandi in Rajasthan, which is a textile hub. So this highlights that nonylphenol is contributed from the textile industry. Also, India does not have a specific standard for nonylphenol, but it does have a standard for phenolic compounds, like which are expressed in the form of phenols. And this nonylphenol concentrations which we found in water was like about 8 times more than the prescribed BIS standard. So what we can conclude from the study is that regarding this chemical, there is not much know-how available or not much awareness among the government officials to monitor this compound in surface water or drinking water. And because this compound is present in such a high concentration in the detergents, it can be a very easy source of nonylphenols to the environment. And as I stated before, the highest concentration was found in the Bandi River in Rajasthan, which is a textile hub, which is clearly an indication of excessive use of nonylphenols. And international corporations or international brands claim that they have phased out nonylphenols in their products, but the study has confirmed high quantity of nonylphenols in the products sold by their Indian subsidiaries. So, what road map we can recommend is that there are globally, if you see in the United States, in the EU or Japan or China, there have been actions to restrict the use of nonylphenol in different consumer products. But in India, only the action has been taken to restrict the use of this chemical in cosmetics. So we need a roadmap to phase out the chemicals in the country. And some of the suggested recommendations are so some of the suggested recommendations are like we have to ban the use of nonylphenols in detergents, and there should be more of impact study or the toxicity studies related to this chemical, and there should be an inventory like how much this chemical is used in different sectors in the country. And if you see, there are only like 3 or 4 studies of the presence of nonylphenol in the different environmental matrices. So we need to do more studies on this. And also there should be a national policy to phase out this chemical. And as I stated before, the India have a BIS standard only for phenolic compounds, not specifically for nonylphenols. And the method which is used to detect the nonylphenol, the method which is used to detect the general phenolic compounds may not be able to detect nonylphenol because of its complex nature. So we need to revise the BIS standard, also the effluent discharge standard for this chemical particularly. So for more information, you can refer to our report, The Dirty Trail Detergent to Water Bodies. And soon we are also coming out with another report on highlighting the presence of this chemical in drinking water. So that study will be released soon. Thank you.
Thank you, Dr. Omkar. The session is now open for any questions if anybody has something. All right, so we will quickly go to the next speaker. Thank you, Dr. Omkar, for your presentation on nonylphenol. Dr. Sanjeev Mohapatra is the next speaker which we have today. Dr. Mohapatra is a postdoctoral researcher in Society of Environmental Toxicology and Chemistry at National University of Singapore. His area of interest includes water quality, environmental health, environmental chemistry, environmental impact assessment, biological wastewater treatment, and hydraulic modeling. He has a total of 293 citations and has immense research experience, specifically in emerging contaminants, pharmaceutical and personal care products, photodegradation, and enzymatic degradation. Dr. Mohapatra, I would kindly request you to deliver your talk now.
Good morning, everyone. So is my slide and my voice is audible?
Yes, sir, it is.
Yeah. Thank you, the team, for the invitation and also for the nice introduction. So today, I was allocated 10 minutes, so I'll try to wrap up within that time frame. So today I'm going to present on the non-target screening of emerging contaminants during this unprecedented time. So so this research we are doing at the National University of Singapore in the Environmental Research Institute. So coming to the mass spectrometry analysis, so we have like three specific approach to the analysis of contaminants. So one is the target analysis, where we are aware about the chemicals which is already present in the sample. And and basically we try to analyze and quantify them with the help of reference standard. But when it comes to the suspect and non-target analysis, for example, in the case of suspect analysis, so we expect that there are certain chemicals present in the sample, and we try to collect their mass data and also try to interpret the results from based on the MSMS data as well as the retention time. So in such a suspect screening, we try to use different platforms such as Norman Suspect Listing Exchange, US EPA Comtex dashboard, even mass spectral libraries such as MassBank and LBMass. So with the help of this platform, the suspect screening approach is quite easy compared to the non-target analysis. So in the case of non-target analysis, we are not much aware about the type of chemicals present in the water sample or even the environmental samples. So what we do, actually, we do a prioritization approach. So initially, after analyzing the sample, we try to subtract the blank, exclude the data which is below 2 minutes or above 24 minutes if it is a 30-minute runtime. So in order to extract quality data. And finally, we also include several adducts that are formed in the soft digestion mode, such as sodium and hydrogen and potassium adducts. Several prioritization techniques, such as hierarchical clustering and other statistical approaches, are being used in order to extract quality information. In order to elucidate the structure, several platforms such as Medfact, ChemSpider are being used for the final confirmation purpose. So in the study that was conducted over here, so basically, as you can see here, the wastewater sample was collected, followed by it was filtered and pH was adjusted. Spike level standards were used for the recovery correction. Then cartridge conditioning, sample extraction, then finally the elution. All this took place, and finally it was subjected to LCMS analysis. So once the sample is ready, either it can go for a target analysis, suspect analysis, or even non-target analysis. So for the suspect and non-target analysis, we have used the LC-QTF instrument, which is available over here. So as you can see here, just by extracting 50 ml of wastewater, we found around 9,000 compounds, which are pretty high. And of course, extracting the information from such a large data set is quite cumbersome and tedious. So in order to extract quality data, like several corrections such as blank subtraction, as well as the exclusion of the data below 2 minutes or beyond 24 minutes. So all those was carried out. So here you can see the mapping of molecular features such as unique features present in the blank as well as the different set of samples. And so by using blank subtraction and other criteria, we have reduced from 9,000 features to 7,000 features. Even though it is a vast amount of data, within that we found around 352 compounds, which is around 6% of the total data set is present across all the sampling points. And if you look at here, like all the sampling point, UN 14, UN 64, USFD and USFD 4 and 13. So around like 12%, 14%, 13%, even 16%. So those are the unique features which are present at the individual data point. Also, as I mentioned, around 6% was common across all the data points, across all the sampling points. In addition to that, there is overlap among the sampling points. So such unique features in each cluster could have been attributed due to a difference in abundance. At the same time, maybe because of any specific events that is happening in those study area. So we did a suspect screening initially in order to identify what are the pharmaceuticals are present, which are not previously analyzed. So what I found, I mean, we found like there are pharmaceutical belonging to analgesic, antiviral, antacid, antidiarrheal, several hormones, anti-malarials, even most importantly, the like some medicine used for the Parkinson's disease and anti-cancer. So these are some of the medicines were found. So okay, so there are certain like we also found several metabolites. So before going to metabolites, I would like to highlight the drug metabolism. So basically, after ingestion of any drug, it undergoes phase 1 and phase 2 reaction, as you can see here. So basically, phase 1 metabolism majorly involves structural alteration of the molecule so that it can be easily absorbed by your body. Whereas phase 2 is more of like an elimination mechanism and making the compound more water soluble so that it can be excreted through urine and bile. So in the phase 1 reaction, which is nothing but oxidation, reduction, and hydrolysis, so it's catalyzed by cytochrome enzyme in the body, whereas phase 2 reaction include gluconidation, sulfonation, acetylation, and methylation to make the pharmaceuticals more soluble so that they can be easily excreted from our body with the help of transferase enzyme. So the reason why I talked about the pharmaceuticals metabolism is because in addition to several drugs, pharmaceuticals, we also found out several metabolites present in the sample. So as you can see here, even there was a recent report, it was found that more than 50% of people, native people, are actually depressed because of the pandemic. And among them, mostly the young generations are quite depressed. And as a result of which they take a lot of medicines, and we found all these compounds, all these pharmaceutical in the wastewater. In addition to that, there are several metabolites were also detected. For example, citalopram, we found both the parent compound at the same time the oxygenation product, which is citalopram N oxide. In case of nortriptyline, we found their gluconide conjugate. And yeah, there is another antidepressant drug for which 3 different kind of metabolites are reported. So we found one of them actually. So coming back to anti-cancer drugs and metabolites, so there are certain novel anti-cancer drugs which are being used for different purposes, such as for chemotherapy, for immunosystem suppression, or for ovarian cancer. So yeah, so mostly for the anti-cancer drugs, we find out there's metabolites, as you can see here, like in the case of here, both primary as well as secondary metabolites. So yeah, to coming to my final slide, so we found more majorly gluconide metabolites, and they are quite related to a lot of medicines that are consumed native in the sampling area. So our objective is to identify these compounds and their metabolites. Also, we are looking into develop a semi-quantitative approach. So basically, in the absence of any standard, how to quantify these compounds present in the wastewater. So probably with the help of quantification, even with just identification, it is possible to identify different zones, basically conducting a wastewater-based epidemiology study from a chemical point of view. So with this, I would like to thank everyone, my research team, as well as my professor and the organizing team of this particular event for inviting me. If you have any queries, please let me know. And also you can reach to me through my following email. Thank you very much.
Thank you, sir. Thank you, Dr. Mohapatra. I would request if anybody have any questions, then please raise your hand so that we can unmute you, or you can put it up on the chat. Thank you, Dr. Mohapatra, for your talk. I would now request everybody to now break for lunch, and I would kindly request all the participants to join us back again at 1 p.m. sharp. Thank you, everyone, and I'll see you again back at 1 p.m. Good afternoon, one and all present here. I welcome you all after the lunch session for WaARISH 2021. The next session will be taken up by our session chair. I'd like to introduce our session chair for the next session, Professor R. Shivakumar. He is an associate professor in the Department of Civil Engineering and Environmental Engineering section in SRM IST and is also a coordinator of the Earthquake Research Cell. His area of research includes geoinformatics for water resources and watershed management, disaster management and mitigation studies, as well as earthquake studies and mitigation. Sir, over to you now.
Yeah, thank you very much. I thank the organizers for giving this opportunity to chair the sessions as well as to get interaction with the people from international and national level. The first speaker is Dr. Sheikh Rehana. She is assistant professor in International Institute of Information Technology, Hyderabad. And her area of research focuses on mainly hydrological impacts of climate change, statistical downscaling, and uncertainty modeling, water quality and management, reservoir operation, and irrigation planning, and also a gold medalist in civil engineering. So without taking much time, I would like to invite the speaker for her presentation. Yes, Dr. Sheikh Rehana, please.
Good afternoon to all. I'm audible?
Yeah, it's clear. Yeah.
Thank you. Is my slides are visible?
Yeah, full view. Yeah. Yes, it's nice. Yeah.
So yeah, good afternoon to one and all. Thank you, Professor Sivakumar, for the nice introduction. So today I'll be going to talk about stream river water temperature modeling and climate change. So I'll be going to cover a few topics on climate change impacts on river water quality, particularly a focus on how we can predict the stream water temperature and how we can use that predicted stream water temperature in estimating the extreme risk of water quality and some of the aspects of baseload allocation model, which can be utilized to optimize the treatment policies and decision-making side. So with that, river water bodies serve as a prominent water resources for various purposes, including baseload allocation. Basically, any river system is subjected to point sources in terms of industries, municipal effluent, sewage treatment plants, etc. Non-point source pollution in terms of agricultural pollution, runoff, etc. So on top of this, on top of this, water resources managers, particularly water quality monitoring agencies, have severe pressure under population growth, rapid urbanization, alterations in agricultural patterns, and unplanned growth in industries. So because of that, one more concern is failure of maintaining the environmental standards. On top of this, there is something called climate change, which affects the river water quality bodies. So water quality is also one of the important criteria for Indian culture and tradition in terms of holy dips and rituals, etc. So with this, risk of assessment of low water quality along the river water bodies is of relevance. With that introduction, climate change has proven to be one of the important driving force in terms of the river water quality. So majorly due to anthropogenic global warming, so we know there are some strong evidences of increase in temperatures and changes in the precipitation patterns, which can have a direct impact on the hydrological variables. So if I pick more importantly river water quality variables, river water temperature is one of the more prominent variable which has a direct impact through the air water temperature changes, and precipitation pattern changes have a direct impact on the stream flows. So which are the most important river water quality variables which can have an impact on the river water quality parameters, for example, dissolved oxygen levels. So with this, so most sensitive river water quality variables has been identified as stream flows and stream water temperatures, which has a impact on the river ecosystem and river sustainabilities and etc. So which actually has a main contributing factors on the risk deteriorations, etc. So there is a necessity to study the climate change impacts on the river water quality and to assess the risk of the low water quality along the river water bodies. So as we have seen, stream water temperature is also one of the important variable which can have a direct impact on the river aspects, ecosystem. We have impact on the aquatic life, etc. So how we define the total heat budget of a water body? So main contributing factors are the inflows and outflows of water in terms of groundwater flow, interfaces, lateral flows, through flows, and more importantly, the atmospheric heat exchange. So which has an impact of the solar radiation, long wave, short wave radiation processes, convection processes, and all these actually happens at this air-water interface. The most influencing variable which actually defines this atmospheric heat exchange is the river air temperature, which has a direct impact on the river water temperature. So conventionally, air temperature actually has been identified as the most commonly used to predict the river water temperature models. So because it is a major component in calculating net exchange of heat fluxes at the water surface. So with that, so river water temperature is expected also to be affected under global warming due to changes in the increase in the air temperature and also due to flow regulations, water withdrawals, etc. So models explaining the changes in river water temperature associated with the changes in the air temperature has become an important aspect and modeling features which has a direct impact on the river water quality modeling aspects. So some of the models which have been used are statistical models which are relating the air and water temperature relationships. One of the preliminary model which is easy to implement where which uses air temperature as the only predictor variable is a linear regression models. So linear regression equations has been conventionally used to relate the air and water temperatures. So there are some models like daily scales, weekly, monthly, and annual scales, which actually works pretty well at the with the good performance measures. So these are the case studies what I have presented here for Vermilion River in South Minnesota, and this is the monthly air and the stream water temperature models for Tungabhadra River, India. So recent one of the case studies also presented used this linear regression model using air and water temperature models for Ganga River in the industrial Kanpur region. They used this linear regression models, so which are easily to implement and pretty easy to integrate in any river water quality assessment studies. So another important feature in affecting the river water temperatures is the stream flow. So in the case study of Danube River, an increase in the water temperature was observed as a consequence of low summer flows. So mainly the river water temperature is inversely related with the discharge as stream flows, where reflecting the reduced thermal capacity and the decreasing flows. We can see a positive relationship between the air and water temperature and the negative relationship between the river water temperature and stream flows. This is the case study of the Tungabhadra for two stations called Shimoga and Honnadi, what is presented. So with this river water temperature sensitivity to air temperature and stream flows has been much interest. So what you are seeing on this slide is air temperature increase for 1 degree centigrade and air temperature increase for 2 degrees centigrade with changes in the stream flows. Particularly, if there is a reduction in the stream flow, so we can see the more impact on the river water temperature is this extreme scenario of increase of 2 degrees temperature, air temperature, and decrease in the stream flows. So this is the case study what I'm presenting on the Tungabhadra River. So one interesting case study what we can see here based on Van Vliet study. So the study picked air temperature and what stream flow various scenarios. So what I'm showing is a critical scenario of increase in the air temperature of 4 degrees centigrade combined with the decrease of 40% decrease of stream flow. So what we can see, most of the locations around the world has a increase of 5 degrees of river water temperature. So with that, so this is one more case study what we have implemented on the Missouri River at Nebraska City, USA. So this study has used simple multiple linear regression which can combine the air temperature and the stream flow. So we can see good performance measures at the daily time scale in terms of R-square values, etc. So we can see the observed and simulated with the multiple linear regression model. And these are the scenarios for various combinations of increase of air temperature and decrease of stream flows. So there is a sensitivity, high sensitivity of river water temperature for this combination, extreme combination of the air temperature and stream flows. So with that, whatever the so far studies we have discussed is about the average time scale river water temperatures, but climate change has a more impact on the extremes. So an extreme scenario of river water quality can be expected when the river water temperature is at its maximum with flows at its minimum. So this is generally expected under the non-monsoon periods of Indian rivers. So there is a necessity to study the maximum river water temperature, that is extreme river water temperature at any particular river location, which can create a worst scenario in terms of the river water quality, particularly in terms of the Indian case studies. So air and water temperature regression models may not preferable at a higher river water temperatures. So therefore, in non-linear regression models can be adapted to predict the maximum river water temperatures, extreme river water temperatures. This is one of the well-known model, which is a 4-parameter non-linear daily stream temperature model, what we can see. So this is where a curve-fitting non-linear log logistic model they have used, where alpha and these mu are all the parameters of upper and lower bound of stream temperature. What we can see, the temperature, stream water temperature has been predicted using this non-linear regression model. So these are the implementations of the model. So this is how the weekly simulated and observed stream temperature for Aroostook River at Cariogu, Maine for the period based on the study of Mahsini et al. And this is implemented on Tungabhadra river system, where the daily maximum river water temperature has been predicted using the non-linear log logistic regression model. So this is one of the important case study where inclusion of the stream flow factor in this non-linear regression model by Van Vliet, where we can see the apart from the Mohseni model, which is conventionally used to predict the maximum river water temperature, extreme temperatures. In addition to that, stream flow has been added, discharge has been added as one of the parameter. And this is the implemented case studies on various river locations along the globe. So here we can see Potomac, Washington, DC, NC, Igrarka, and River Oak. So quite good satisfactory models, particularly when we have added the stream flow and particularly when we used these non-linear regression models in prediction of the river water temperature. So in addition to this, when we talk about the non-linearities and extreme conditions, machine learning algorithms has proven to be the best and robust models. So machine learning models are more comparable and more promising models when compared to the process-based models, which are based on the advection, dispersion, and equilibrium temperature concepts, because these process-based models request a lot of hydrodynamic data set, hydrological data sets, and catchment details. So apart from that, there are several case studies which actually try to implement machine learning algorithms by combining not only the air temperature, but all the other variables, most sensitive variables also, like solar radiation, flow discharge, riparian shade, landform attributes, etc., using the machine learning algorithms. So the general procedure, the flow chart here, so identifying the most sensitive variable in affecting the river water temperature, particularly to that region specific, we need to consider. Then we can identify the how we can train the test and any machine learning model. It can be a ridge regression, it can be random forest model, it can be a support vector regression, any based on the time lag effects consideration. And when we try and test, we test the performance measures in terms of various performance measures. So this is if the performance is not satisfactory, again we go to identify the optimum parameters and to train and test the model to achieve the best performance measures. So this is an implementation of the machine learning algorithms. What we can see here, the river water temperature again implemented on the Tungabhadra. So this is based on the multiple linear regression model, and this is the support vector regression model. So based comparable to machine learning, regression models, machine learning models are robust to predict the river water temperature, accounting for the non-linearities and complexities in the nature. And it is accounting for including various hydrodynamic variables also, which are sensitive and region specific. And whenever there is a data limitations also, we can use the machine learning algorithms. So machine learning algorithms to predict river water temperature has gained a lot of interest in the research, and it has useful for integrating the scientific knowledge into the machine learning tools for improving the predictions of the river water temperature. So how we can use this predicted river water temperature models in assessing the river water quality assessment. Whatever the flow chart you are seeing on the slide is about the climate change impact assessment on the river water quality. So basically we use the general circulation models, which are sophisticated climatological models which produce the climatological variables such as air temperature, mean sea level pressure, etc. at higher resolution for current as well as future scenarios, accounting for the greenhouse gases into the atmosphere. So using this GCM outputs, what we will try to relate is the regional scale hydrological variables. Particularly for the river water quality assessment, we use the air temperature and stream flow as the main influencing variables. We try to downscale the air temperature and stream flow of area of our interest, river stretch of our interest, using various climate change projections models. Basically, we have the change factor method, statistical and dynamic downscaling models. Change factor is a method where we will try to add the historical percentage changes, historical changes to the current GCM outputs to get the how much sensitivity in the future can be expected. So using this climate change projections, we can integrate with any river water quality simulation model to assess the river water quality indicators. And these indicators can be integrated with the optimal fractional removal level policies to assess using the waste load allocation model, which I'll go into explain in the coming slides. So what is the current state in the aspect of climate change on river water quality in Indian perspective? So most of the studies has identified the stream flow and river water temperature, and the pollution load. Apart from that is the three main influencing variables. So mainly the various scenarios has been generated based on the general circulation model outputs or else hypothetical scenarios on stream flows and air temperatures. for studying the river water quality input variables. So these scenarios goes as input to the river water quality models. Most of the studies studied at the river stretch based or location based using river stream water temperature or stream temperature or river water quality simulation models. For example, Qual2K is one of the well-known model, or else we can use any river basin catchment scale model also. For example, soil, water and assessment tool, which actually can simulate the water quantity as well as quality aspects. So what are the main indicators used for the study to represent the pollution load, etc.? Dissolved oxygen and pH has been considered, and to represent the agricultural pollutants, nitrates and phosphates has been used. To represent the industrial pollutants, BOD, COD, nitrates and phosphates has been used in some of these studies. So now using these climate change concepts and stream water temperature model concepts, etc., how we can assess the extreme risk of water quality under climate change. So when I talk about the low water quality, how we define the low water quality? So basically we define the low water quality when there is a less or the water quality indicator is above or below the threshold. So for example, if I take the dissolved oxygen level, if it is less than the minimum prescribed limit by the pollution control boards, then we define the low water quality as 1, and the risk of low water quality as the probability of occurrence of this low water quality events. When we define this probability of low water quality risk events, we can estimate this for current as well as for the future scenarios. So this is the modeling aspects where we use the GCM outputs, as just now I have explained, using the statistical downscaling models. So where we use the projections of air temperature and stream flow. So using the air temperature projections, a nonlinear air water temperature model can be used to predict the maximum river water temperature. For any particular Indian case studies, the seasonality is more important. So we are predicting, try to monthly maximum river water temperatures, particularly for the summer months. So during the summer months, we expect the minimum flows. So monthly minimum 7-day average consequent low flows has been considered for this analysis. This is generally considered as the design flows in any river water quality assessment studies. 7-day low flows is the design flow generally considered. These two goes as input to river water quality simulation model Qual2K, and the Qual2K model can simulate the dissolved oxygen levels. So we define this based on this concept, the risk of low water quality. So which we define that as an extreme river water quality, risk of low water quality. So what we have implemented this model on the Tungabhadra region. So what we can see the observed and future low water quality events. So here for a given threshold of 4, 5, 6 mg, 7 mg per liter of dissolved oxygen levels. And these are the results of the extreme river risk. So for the current, there is a 3% of the risk of low water quality, and future average risk is at 4.5%, whereas the extreme risk will be at the 50.6%. So there will be a significant increase in the risk of low water quality and the changes in the stream flows and the changes in the river water temperatures. So now coming to the waste load allocation model, whatever the risk component we have calculated, so that can be considered as the goal of the pollution control boards to minimize this risk of water quality. So when we define the objective of the pollution control boards as a minimize this risk of low water quality, what is the goal? There will be a goal of this industries also to minimize the treatment levels. So there will be a conflicting goals of these two. So there should be a optimum optimization techniques we need to use. Here we are using the fuzzy optimization technique where the goals of the pollution control agency is defined by this membership functions and task satisfaction level. So where the minimum, if for example, if I see this is the dissolved oxygen level, right? So this is the minimum dissolved oxygen level and this is the maximum. So prescribed by the pollution control boards. As the DO level is increasing, the satisfaction level is increasing. this is the goal of the industries. So this is the minimum treatment level and this is the maximum treatment level suggested by the industries. So as the treatment is moving higher side, their satisfaction level is decreasing. So with these two conflicting objectives, we define this as the maximize the satisfaction level with the constraints of the constraints such as the dissolved oxygen level should be within the minimum and maximum set by the pollution control boards, whereas the treatment levels should be in between the minimum and maximum prescribed by the industries. So where we try to minimize the satisfaction level of these pollution control boards and the industries. So with this, we can implement on the Tungabhadra case study we have implemented, and these are the resulting DBO levels, what you can see for current as well as for the future scenarios at various checkpoints. For example, checkpoint 2, the dissolved oxygen levels are deteriorating to 3.56. For checkpoint 10, it is 4.5, and so like the checkpoint 14, it is 4.3 mg per liter. So these are the fractional removal levels in the sense treatment levels for set by each industry discharger, basically for current as well as for the future scenarios. So to be noted that these fractional removal levels are estimated when the industries are maintaining their minimum standards. That is effluent load, whatever the releasing is at their minimum standards, even though the treatment levels actually has to be increased under the changes of the stream flows and the temperature patterns where the risk of water quality is getting affected. So with this, to summarize, basically what we have understood that most sensitive river water quality variables are stream flows and river water temperatures, and we have seen how we can use the various regression and machine learning algorithms to predict and to forecast the stream water temperature for average conditions, for extreme conditions as well, and how we can integrate these two aspects to water quality simulation model. Let's say, for example, any stream water quality model, for example, Qual2K, to identify the water quality indicators. Let's say, for example, dissolved oxygen level is the example what we have considered. So based on the dissolved oxygen levels, we define the risk of water quality whenever there is a threshold is deviating from the standards prescribed by the pollution control boards. So based on the objective of the minimizing this risk of low water quality, we can go for the optimal policies using the waste load allocation model, which is basically a optimization model to optimize the treatment policies. So these studies will be really helpful for the decision makers and water quality monitoring agencies to make the decisions and policy level. So with this, so far, whatever the studies we have seen is at the river location based or stretch based or over some kilometer distance locations we have studied. So whereas the driving factors are more towards at the catchment scale. So what we can see here is, so there is agricultural pollution, industries, and the driving forces are urbanization, land use change patterns are there, vegetation factors are there. And on top of that, we need to consider the changes in the atmospheric precipitation patterns and whatever the runoff pollutions adding into the catchment scale. So with this, we need to study a catchment scale river water quality risk assessment model, which can be implementable at the catchment scale. So where we can try to integrate a hydrological model, a river water quality assessment model, where we can use the our waste load allocation model to minimize the risk of water quality along the river water bodies. So with that, I would like to acknowledge so the project work we are doing is basically support is coming from the SIR project, and the government body which we are getting the data is Advanced Center for Integrated Water Resources Management, Government of Karnataka. And finally, I would like to thank our Hydro Informatics Research Group at IIIT Hyderabad. Thank you. Any questions?
Yeah, thank you very much for your nice presentation. Especially for machine learning you have touched, as well as for the GCM related And also the future prediction for 2040, you have given a nice information as well as quality as well as temperature. Now this paper is open for discussion or one or two questions from the audience, please. You can able to put it in chat box also. Any questions? Any questions? Okay. Anyway, I would like to know one or two just some doubts I'm having. You already predicted for 1988 to 2005 20 degree, after that 23. Then 2040, 2020 onwards 24 degree. You have given the predicted temperature. Any validation has been done for 20 or 21?
Yeah, I think
Yeah, please.
these type of models you're talking about.
Yeah.
Learning models, basically.
Yeah, I have seen their output. Yeah.
Yeah. So basically, when we train the models for the observed conditions based on historical data sets, basically historical and measured data sets. So when we do the predictions using the general circulation models, we'll try to validate with for the observed data period also.
Okay.
So that how the GCM is able to predict the historical conditions, basically.
Okay.
So based on that confidence, I think in one of the study, I think I have mentioned that. So based on that confidence, how the general circulation models are able to capture the current variability of river water temperature or stream flows, etc. So based on that confidence, we will try to predict for the future.
Okay. So I think you can continuously monitor this, right? Maybe some field-based monitoring you will be doing, so that you can able to validate very well for this, because it's 20 to 2040, it is shown 24.67 degree. Maybe definitely it may be giving you a very good insight into the future predictions. Okay. So any more questions? Any more questions from the audience? Any more questions from the participant? You can put it in chat box also. I think there is no more question. Thank you, Dr. Rehana, for your nice presentation. So anyway, we'll be touched in related to surface water quality. Already SRM also we are doing with madam. Surface water quality, specifically lakes and everything. Anyway, it is very informative. Thank you very much. Yeah.
Thank you so much for giving this opportunity.
Yeah. Okay. So now I would like to invite Dr. R. Selvakumar. Yes, Dr. R. Selvakumar, who has received his postdoctoral fellowship in Indo-US WaARISH Fellowship, University of Nebraska, Lincoln, and his postdoctoral research fellowship, Endeavour Research Fellowship, University of Newcastle, Australia. He has received Invention Award on fabrication of three-dimensional scaffolds of tissue engineering, and have been selected as emerging water professional for EWPP program in the International River Symposium. His core research area includes water purification using microbes and nanomaterial, nanobiotechnology-based approach for tissue engineering, and he has a lot of publications and other thing. And now I invite Dr. Selvakumar for his presentations. Thank you.
Thank you, Professor Sivakumar sir. I'll just share my slide. Okay, is the slide visible?
Yeah, make it full film.
Yeah. Okay.
Oh, nice.
Yeah. Very good afternoon, everyone. And first of all, I would like to thank Dr. Paramita for inviting me to present my work. And I also thank Dr. Sivakumar for the nice introduction. So basically, here I'm going to share some of the insight what we have on treatment of groundwater as well as hospital wastewaters or effluents, which has been contaminated by antibiotic resistant bacteria. Okay, as you know that this is a hot area, and a lot of methods have been invented to just mitigate antibiotic resistant bacteria from water sources. So being a health area, and it is very important for us to get rid of this antibiotic resistant bacteria, because the entire health sector depends on how much we can prevent this antibiotic resistant bacterial growth, even in water or any medical devices, or even in hospital surfaces. So considering this, the spread of this antibiotic resistant bacteria in hospital zone is very high. and not only the hospital zone, but also it reaches the groundwater through the treated effluents. Okay, so as I mentioned, it is treated effluents because currently we don't have a mitigation technology to especially counter antibiotic resistant genes and bacteria present in the effluents. Okay, so this is a PhD work. I'm presenting a PhD work of one of my student, Nitya. So she is working on this in this area for the last 2 years, and just with a short introduction about this subject. So as you know that the hospitals and the healthcare facilities present in our regions have they generate a lot of effluents, and especially these effluents are very much rich in antimicrobial components. Okay, so as the level of antimicrobial components present in the water increases, there is always a possibility of increase in the development of antimicrobial resistant bacteria in the water. Okay, so the main source of these antimicrobial components is either the medicines which we give to the patients or the surface sterilization process what we do with the help of antimicrobials. And not only that, even the stool and the urine samples which goes into the main effluent stream also carries a lot of antimicrobial components which are being used to treat the patients. Okay, so therefore they are the major source of the antimicrobial compounds, and eventually when a non-resistant bacteria comes in contact with this one, initially it dies, but slowly it develops an antimicrobial resistance against the compound. So therefore, the wastewater treatment plants from these hospital waste effluents, the treatment plants which are used for these hospital waste effluents are hotspots of antibiotic resistance spreading. Okay, so because of its health concerns, WHO has called it as a priority area, and they have especially mentioned it as an urgent priority area because the level of increase in antimicrobial resistance is increasing drastically, and even now the most harsh antibiotics are the bacteria are developing resistance towards those antibiotics. Okay, so there is a global concern for this, and WHO has prioritized these antibiotic resistant bacteria as critical priority, high priority, and medium priority. And if you see that the critical priority or having the bacteria which are classified under critical priority includes Acinetobacter, Pseudomonas, and Enterobacteriaceae, and especially for antibiotics like carbapenem. Okay, so carbapenem is having more resistance, is inducing more of resistance in this bacteria, followed by cephalosporin. Okay, in case of high priority, if you can see, the vancomycin resistant bacteria plays a vital role. So most of our research are in the high priority zone where we focus on vancomycin resistant organisms, especially Enterobacteriaceae group, which is involved in this. So in case of the medium priority, if you see, the penicillin, ampicillin, and some fungal fluorocones are also coming under this category. And the organisms, if you see, the Streptococcus, Haemophilus, and Shigella species are mostly in the medium priority region. Okay, so if you can now, this clearly indicates that the diversity present in the antimicrobial resistant bacteria is very high, and it is quite spreading. Okay, so essentially we have to focus on how we can mitigate these organisms present in the effluents or when they eventually leach into the groundwater. Okay, so it has one study did by Calero et al. They have clearly mentioned that the resistant bacterial strains which are present in the sludge and from the ETP is reaching up to a level of 10 to the power of 8 gene copies per gram of sludge. That means every gram of sludge, you have almost 10 to the power of 8 resistant genes copies present in the sludge. That means that the sludge itself becomes a source of antibiotic resistant gene transfer, and therefore it has to be properly treated before we use it for some other sources, for some other applications. Okay, so a small introduction. A hospital waste effluent, usually it has and microbial contaminants, and it has suspended solids, it has pharmaceutical compounds, and even sometimes radioactive substances and metals. So these are the four major composition of the hospital wastewater, and they are generally treated using the conventional treatment units present in the ETP. Okay, so for example, you have primary, secondary, and tertiary. Okay, but however, the antibiotic resistant bacteria can easily go through this treatment system, and they can evade this purification process. Okay, and therefore they can still spread. Although you are treating the fluid, but you are not going to kill. The treatment technology is not sufficient enough to kill the antibiotic resistant bacteria. Okay, so therefore we have to mitigate this antibiotic resistant, antimicrobial resistant bacteria present in the effluent through a defined process. So among the various technologies present, phages are most important one, and they have been widely used against AMR mitigation. Especially you can see that they are applied in natural water sources, where, for example, in case of cyanobacterial blooms, they have been used to kill the blooms, cyanobacterial blooms. And then you can also treat the multi-drug resistant bacteria present in wastewater streams. And in case of corrosion causing bacteria, you can use phages to just kill the biofilm forming bacteria in the water collection systems. And in case of cooling towers, especially to avoid biofouling, we can use phages. And you can also similarly see in case of agricultural drainage, you can use phages. And in case of water treatment facilities, especially where you are using disinfectants, we can use phages instead of disinfectants. And definitely this can have a better impact on the biofouling and clogging of membranes. So they can prevent the sludge formation through the by avoiding disinfectants in that, but just by using a phage, you can get rid of the microorganisms causing this biofouling and clogging. Okay, so similarly, the biofilms in case of water distribution systems, we can use bacteriophages. So small introduction about the water bacteriophages. Bacteriophages are small viruses which can grow inside a bacteria. Okay, so grow inside bacteria, and they can even lyse it. Okay, so there are two types of life cycles which the bacteriophages follows. One is the lysogenic cycle, another is the lytic cycle. Okay, you can see here. This is how the bacteriophage. This is normal bacteriophage, where you have the spikes which are used to sit on the bacteria, and then it injects the DNA into the membrane, and then the viral DNA they either undergoes a virulent cycle or a temperate cycle or a transducing. They become a transducing bacteriophage. Okay, now in case of once these bacteria attaches to once this phages attaches to the bacteria, they inject the DNA into it, and then it ultimately leads to the lysis of the bacterial membrane. Okay, and therefore the progenies which are made inside the bacteria, they are released into the water. Therefore, they can infect the other set of bacteria belonging to the same species. So the second cycle, what it can follow is the temperate cycle or lysogeny, where these bacterial genes are incorporated into the bacterial chromosome. The phage genes are incorporated into the bacterial chromosome, and therefore they can grow along with the bacteria. And finally, under an unwanted circumstances or unfavorable circumstances, they can be converted into a virulent phage, and they can cause lysis of the bacteria. Or they can simply transduce. They can be a transducing particle where they can bind with the extra chromosomal DNA, and then they can be circulating within the bacteria generations after generations. Therefore, you are having an antibiotic resistance gene incorporated into the plasmids. Okay, so these are the various aspects of bacteriophages. Now, how we can use the bacteriophages in ETP? This is a conventional ETP treatment system where you have all the grid screens and alum with polymers are used. Now, especially when in case of these phages are applied in the secondary treatment system, where especially like settling tanks. So the basic advantage is that the settling tanks allows them a particular time, okay, for the bacteria to interact with the bacteriophage. So the bacteriophage and the bacterial interaction is promoted when there is no disturbance in the water medium. Okay, so therefore the settling tank is the best stage of ETP where you can use the bacteriophage. And there are 2-3 reasons because of why we use settling tanks as a treatment modality for the phage. Basically, when you add a consortium of phage, it can take care of all the bacteria which is growing inside the which is present in the water. Okay, and therefore the settling tanks becomes a reservoir of phages instead of reservoir of bacteria. Okay, therefore it also has an impact on the sludge. The reduced number of sludge is formed, and after that you can send it to the normal BAF and PEPs, and therefore you can get it discharged after UV. So therefore ETP in case of ETP, secondary treatment, especially settling tanks, are the best spots where you can employ a bacteriophage. And again, now recently the filtration systems are also being explored for using bacteriophage based mitigation of bacteria. Okay. So what is the advantage? Almost every stage of the treatment system we can use phages. Basically in water distribution systems, what is like monitoring of water quality. For example, if you have a particular phage, then it indicates that there is a presence of a pathogenic bacteria in that, or there is a possibility of biofilm formation. So it becomes an indicator. And similarly, it can eliminate other harmful bacteria present in this, and they can reduce sludge, as I mentioned earlier. And in case of the natural systems, we can these bacteriophages can be used to reduce the blooming. Okay, like algal bloom, we can prevent by using phages. Okay, so these are some of the advantages using using phages in wastewater contaminations. Okay, so various researches have been done on this slide, and this is a consolidated slide, which is a consolidated table which has been adopted from G et al. 2021, where they have clearly mentioned that which type of phages can be used against which type of pathogenic bacteria. For example, the coliphages, where we have worked extensively, and I'll show you some of the results which we have did. The coliphages, which especially the Podovidae group of phages, have been effective in neutralizing E. coli in the water. Okay, so similarly, there are different sources from which you can isolate the phages, and these phages have been effective against various pathogens. You can see that Vibrio cholerae, Salmonella, Pseudomonas, Klebsiella, all are pathogenic microorganisms associated with the hospitals and hospital-borne infections. So they can be mitigated using the bacteriophages without using any chemicals or any antibiotics. Just by using bacteriophages. So there's a lot of potential of using these bacteriophages against the pathogenic bacteria, especially in water system. As I told earlier, bacteriophages have been used as a water quality monitoring and tracking. So the coliphages have been extensively studied, and especially the somatic coliphages, which are specific for E. coli strain WG5, has been used as a water quality monitoring parameter. And these bacteroids phages like Bacillus fragilis, Bacillus tetamicromium. So all these things are effective in monitoring the water quality. Okay, so if you can isolate these bacteroids from the water, then it indicates that there is a presence of some pathogens in the water system. Okay. So the same thing can be used for tracking of the treatment system. So with a small introduction, I will go into our work, what we have did. And in our group, we have been working on this line for last 2 years, especially on development of a bacterial phage, which can mitigate vancomycin resistant bacteria. So the problem with vancomycin resistant bacteria is that it is a nosocomial pathogen. That means these bacteria develop resistance from the hospital and then spreads through the hospital. So it's basically a hospital-borne infection causing bacteria. And almost 20% of the nosocomial infections are because of the WaARISH. Okay, because of its infectivity and because of its the spreading nature, ICMR has called or identified them as a national. They have included them in the National Program on Antimicrobial Surveillance as per WHO guidelines. Okay, and therefore there are a lot of genes which are responsible for this vancomycin resistance, starting from vancomycin B to G. And if you can monitor any of these genes, then we can have a tracking of the spread of the vancomycin resistant genes. So conventional effluent treatment plant, as I said before, there is not much reports stating that the conventional effluent treatment system can remove these WaARISH. So therefore we need a new mitigation system. Okay, and we have been looking at bacteriophages as one of the effective mitigation systems for killing vancomycin resistant bacteria in water. Okay. So we collected hospital waste effluent from our sister institute, and you can see here the fresh water is being used by hospital as well as the canteen, and from the hospital it is used in for domestic purpose, laundry, and in case of labs. Especially in our hospital, what we are doing is they are pulling up the laundry and the lab effluents and together, and they are sending it to ETP, and from that it goes to the sewage treatment plant, and then it is being used for garden. Okay, so this is the regular flow of the effluent from the hospital, and the sewage treatment plant and the ETP are good sources of the phages, and therefore we have isolated bacteria as well as bacteriophage from ETP. And the ETP water was collected and it was centrifuged, and we harvested the bacteriophages present in it, and we stored it at 4 degrees Celsius for further studies. And parallelly, we also collected groundwaters and adjacent to that, and hospital effluent, and we characterized them using ICP-OES and ion chromatography. And one of the major factor for binding of the phage to the bacteria is the presence of magnesium and calcium ions. So if you want to use bacteriophages, definitely there should be a presence of magnesium and calcium ions, because without magnesium and calcium ions, bacterial interaction is not possible. Okay, so therefore we have to monitor magnesium and calcium ions presence in the groundwater or even in the effluent treatment, the effluent collected from the hospital. So we did an ICP-OES of the hospital effluent, and we found that there are presence of a lot of ions, and starting from calcium was abundant, and therefore we could get possible interaction of the phage in this one. Magnesium, we didn't have the standard. So however, when we studied using IC, we found that magnesium was there, and ETP had sufficient amount of magnesium. If you can see here, it is 65 ppm, and therefore we had sufficient amount of magnesium as well as calcium in the ETP. Therefore, you can use bacteriophages in ETP. Yeah, so these are some results what we have got. If you can see here, this is a control broth where the bacteria is growing, and this is controlled. So therefore, only the bacteria is there. And once you add the isolated bacteriophage, the bacteria doesn't grow, and it becomes crystal clear even after the incubation period of 24 hours. So the lysis of the bacteria was visualized using the double layer method, agar plating method, and you can see here these are the plaques which are formed by the lysis of the bacteria by bacteriophage. So we did a concentration based study, and here you can see that when you increase the load of virus or the bacteriophage or on the vancomycin resistant bacteria, you can see that as the increase in the viral concentration, the zone of lysis is increasing. Therefore, the concentration dependent study has to be done for effective optimization of the effluent treatment process. So this is a normal SEM of the bacteria, what we have isolated, vancomycin resistant one, and then after infecting with phage, we could find that there are some spots like this and this where you can visualize the phage bacterial interaction. Okay. And this is a HRTM image of the bacteriophage which we have isolated, and this is a control bacteria without any phages. And once you put this bacteriophage to, once you allow the bacteriophage to interact with bacteria, you can see the defined attachment of the phage onto the bacteria, and finally the complete lysis of the bacteria was observed. And we could classify this as a T7 bacteriophage belonging to Podoviridae family, and based on the morphological characterization. This was a Podoviridae family, and it goes in alignment with the already published data in the water field. So we after this study, what we did is we mass multiplied the bacteriophages, and we did a particle size analysis of the phages as well as the bacteria. As you can see that the bacterial samples were more than almost 1 micron, and in case of the phages, you can see that it was below, mostly in the range of 50 to 120 nanometer in size. So the phage bacterial size was determined, and then after that, what we did is we wanted to analyze how this bacteria and the bacteriophage interacts with the different pH and different concentration of vancomycin. And you can see this is a PL study, photoluminescence study, where the first one is a positive control, where we have the live bacteria, and second one is a negative control, where we have actually killed the bacteria, and the third one, if you can see here, the fifth one and 7, all are only bacteria. So the luminescence this side are all live, and these ones are all dead ones. Okay, so once you put the bacteriophage, and along with, in the presence of vancomycin, even in the presence of vancomycin, you can see a lot of bacterial killing in the presence of phage as well as in the presence of vancomycin. Therefore, from this research, it is clear that the phage lysis is induced by the bacteriophage, and therefore it can be used in the water treatment process. We also confirmed the results with the facts, and we could find that this is a control bacterial which is having live bacteria, and once the phages are being added to the bacteria, you can see a lot of dead cells here. So the live dead analysis clearly indicated how much is the efficiency of the bacteriophage in killing the vancomycin resistant bacteria. So we also optimized the impact of pH, temperature, and the vancomycin concentration. Yes, sir.
Sorry, Dr. Shivakumar. Just
yes,
you have another 3 minutes, right?
Yeah,
yes?
yeah, I'm
okay.
finishing it.
Okay, thank you. Thank you. Sorry for this.
Yeah. So
yes,
pH 5 and 7 was good enough for the bacteria to infect the phages, and in case of temperature, 37 degrees Celsius was optimum. And in case of the vancomycin, you can see here the lower concentrations were effective. So we also did impact of the TDS, and we compared all our results with milk water and a direct ETP sample and groundwater. And another one was SM buffer, which is known for the these bacterial phage interactions studies. Okay, so we found that the TDS does not have much impact, and anything above 250 was clearly giving a complete lysis when compared to bacterial growth. Okay, so bacteria grow nicely in up to 1,000 TDS, whereas once you put the bacteriophage into it, you can clearly see here there was no growth of any bacteria in the plate. So indicating that there was a complete lysis of the bacteria once you add the phages. Similarly, we also did the TDS study with in the presence of vancomycin. We varied the TDS from 250 to 500, and on all this set of results clearly indicate that the bacteriophage was efficient in lysing the bacteria. So we also tried the same thing with the actual ETP effluent, and these are some results. You can clearly see in some strains there was too numerous to count bacteria, which was reduced drastically, and in some cases even only, if in this case 500, only 3 cells were there. In case of 250, only 1 cell was there. So 1 colony was there. So all these things clearly indicate that they are efficient in killing the vancomycin resistant bacteria. Now we are trying to develop a filtration membrane using the bacteriophage incorporated into the membrane. And yeah, so the basic conclusion is that they can be used in groundwater as well as in hospital effluents for the killing of vancomycin resistant bacteria. So I acknowledge Dr. Zuli and Yusamli. Actually, the bacteriophage work was started in Department of Civil Engineering, University of Nebraska, USA. And I also want to acknowledge Dr. Raja Dharmalingam for funding the second set of research at PhD Institute of Advanced Studies. I thank Aussdf and WaARISH for the WaARISH fellowship. And I also thank PhD IMSF for the affiliates. Thank you.
Thank you very much, Dr. Sivakumar, for your very nice presentation on bacteriophage mediated lyse. Especially, you discussed about the hospital waste and then what is the impact on the groundwater as well as the surface water. Yes. And especially, you have very high priority zones already discussed. It's very nice and very informative. Actually, it requires a lot of time actually because a lot of research is being carried out, but due to some shortage of the time, so we could not able to go much detail onto that. Maybe I will allow 1 or 2 questions from the audience, please. 1 or 2 questions from the audience. Any questions? Yeah, I think there is no questions from any of the audience. Maybe they may be still thinking on that. That's nice, actually. Very informative also because we are all facing the same problem, COVID-19. Lot of hospital waste is going to come, right? Already it is there. Yes. I don't know how much of research is being carried out in that in the hospital waste I'm talking actually. So it may be a good bloom for the young researchers. Anyway, thank you very much, Dr. Sivakumar, for your nice presentations.
Thank you, Professor. Thank you.
Now, I would like to make, thank you very much. I would like to make one small announcement. I request the participants to proceed to the Slack platform so that you can able to present your posters in that. Okay? Yeah, please. We'll be joining there. Thank you very much.